have any kind of background in Python.
Yeah, it's been like 18 plus. That might be right. It might be better to ask Dan, but I think that's not
Something needs to be done. I'm going to suggest that he's
experimental. The class here, right? It's kind of an experimental thing this semester.
Which?
The program.
The student one? I think so, yeah. It's an actual class, a number class that has an advisor as well. Or not an advisor, faculty member, seeing it, but yeah, it's a trend. I think so, yeah.
Right.
Yeah, we did part of it. I forget.
Chatting with him when
Yeah.
78% should be good.
Oh yeah.
Did find out for some reason if you plug like your iPad or iPhone in here to charge, it won't charge unless you power the laptop through there. Like you have to plug your power adapter into there and plug that in there to get anything to charge off that board. Which powering this is the recommended thing anyway.
Seems like good practice, but it is curious. It's like the high power's only going one way.
Yeah. Okay. Especially since the first thing is activity.
Mm-hmm.
Get rank.
Yeah.
Screen share.
No.
Okay, so I think we'll go ahead and start picking back up. Before lunch, we talked about pulling out the X and Y projection variables out of the data set. So go ahead and do that to your data set. Put your green stickies up as soon as you get it done, and then we'll go on and start making some plots.
We need some more good whistleblowers.
Well, you need Brian Shorn. I mean, he's.
So go ahead and parse your data sets like we did before lunch with the X, Y, and projection variable. And then in about 5 minutes, we'll move on and start making some plots.
Yeah. I'm not sort of private. I mean, this looks like the way very similar. It's also price growth. Well, bless you. I should go to inside you.
Do it live.
The first time she had it. The second.
Okay, I see quite a few green stickies, so let's go through how to do this. I'm gonna live code it up here with you, so if you got stuck somewhere or wanna check what's going on, we can do it together. So first we're gonna list the variables in the netcdf file that we opened. So I'm gonna list, in our netcdf file we called it ds. I'm gonna list the variables, ds.variables. We see our xy, the projection variable, and the sectorized CMI variable. Next, ask us to assign sectorized CMI to a local variable. Blow that up a little bit, might be a bit easier to see. So I'll just call it data var from ds.variables, sectorized CMI. Remember, tab completion is your friend here. Saves you some keystrokes. Then I want to print out the properties. So print data var. There we see shape, all the different attributes. Okay, so now we want to get the x and y variables. So say x is ds.variables. It's x. And since I want to get the actual data values, not just the variable object, but I want to get the array back, follow as an empty slice. Same thing for y, ds variables, y, and an empty slice. And then we want to get the projection variable and show what's in it. So projvar ds.variables. Remember, now we're going to, we could hard code, so I could Lambert projection like that, but it'd be more versatile to use the grid mapping attribute that's on the data variable. Is everybody good with that? Okay. Now, as promised, we're finally going to get to make some plots. So we've got our familiar imports, matplotlib, and the inline magic. How many people are familiar with the imshow command? Matplotlib, a handful. So if you pass imshow an array, it's going to take that array, assign a color map to it, and just show that as a grid, XY grid. If we do that, we get this lovely image. It's not projected, I believe. Without doing anything, it's going to be upside down in this case. But we do have a visualization of our data. And again, in that feared is color map. So we're going from a blue to a light yellow, something we're not used to seeing.
This is a random question. Why do you need the pyplot show underneath the IM show? You can just use IM show, correct?
Think,
Yep.
yeah, that'll work in here.
Depends
Yeah.
if it's inline or not.
Yeah, if you don't have the inline magic, you would have to have that.
So can I ask what's the difference between IMShow and just doing a plot? Like, is that a specific kind of plot or?
Yes.
You mean like plot.plot?
Yeah, like,
Okay.
or like if you were to do like a.
Yeah.
Yeah, I'm just curious what the IMShow is for.
So one thing, if we look at, of course. So data var is a two-dimensional thing, right? So let's just pass. So what we now have, I'm going to put a semicolon there to suppress that so I don't have to scroll all the way. What we now have is a line plot for each row in that two-dimensional array.
So is IMShow just like a P color or a contour kind of
P color.
device?
Like P color, except assuming every pixel is the same exact shape.
Every what is?
Every pixel, every quad in the P color.
You don't
It's the
define
same.
any edges.
Okay.
It's just taking a pixel, putting the
Much
value in the array.
faster.
Right. Yeah. Okay. Because yeah, he's equal.
But if you wanted to, say, take some random row from this data set and you want to plot the value of transect, that's what. So there we're taking the 45th row, and this is scanning across Y, the values that are coming back. But what we really want to do is do some kind of projection to get it into something that looks realistic. Ryan already showed you Cartopy and its coordinate reference system, our CRS sum this morning. Let's remind ourselves what's in the projection variable. We've got the standard parallel, longitude central meridian, latitude of the projection origin, and then these globe axes. So we're going to import the Cartopy coordinate reference system as CCRS, again, because we don't want to type. And then we have to make a globe object that specifies what Earth we're going to project this on, what we're going to plot it on. If we zoom out a little bit, maybe we'll get it all. Is that too small to see in the back? Yeah, okay. We'll blow it back up. So we call Cartopy coordinate reference system .globe. We're using a sphere. Semi-major axis is projvar dot semi-major axis. So we're getting this metadata attribute off our projection variable. And then for the semi-minor axis, we're getting the semi-minor attribute off the projection variable. And that's all we need to specify the shape of the globe that we use for this projection. Now we need to tell it about what actual map projection we want to use. We know we're going to use the Lambert conformal. This is one place where if you're making this general, things could break down. There's not an easy way to pick this projection and provide all the information needed to Cartopy automatically. So here I'm hard coding that I'm going to use the Lambert conformal projection here. So this would be one place things could potentially break. And then we specify, so here's the central longitude central meridian, the central latitude we get from the projection variable. And then we have to specify the standard parallels. Cartify will accept more than one here. It's expecting a list. So we have to make sure that we wrap the one standard parallel that we've got in square brackets to make it a one element list. Otherwise, Cartify will be unhappy. Go ahead and show you the error message you would get. So it says that this has no length. It's expecting a list that would have a length attribute. Put our brackets back in, and it'll run fine. And we pass it a globe object, so it knows the size and shape of the Earth. Okay, we're getting pretty close to be able to plot this data. I went ahead and printed here so you can see the minimum and maximum values of X and Y. These obviously don't look like Latin lawns. That's why we're having to do all of this projection. I just wanted to show you what those values look like that are in the X and Y arrays. And now we're going to make our plot. So we make a figure object, just like we've been doing the last couple of days. We're going to make it a 10 by 10 inch nominal figure. Here, has Ryan shown you the add subplot method?
We used it earlier.
Okay, yeah. So we're going to have one row, one column, first plot. And now we have this additional argument, of course, like you had earlier. I'm going to use this projection. Then I call ax.imShow again. Here I pass my data variable, like we did before. Specify the extent. See if I can get this to scroll. So the minimum and maximum in X and Y are longitude and latitude that this map is going to go over. And specify that the origin is in the upper corner, not the lower corner. Otherwise, things will be flipped on you. And I'm going to add coastlines so we get some idea of where we are. So if we run that cell, you can see the coastlines aren't very helpful. Whichever picture I've picked has this little sliver of coastline right now, of course. Is anybody doing CONUS or anything like that? Yeah, so you see more, you see the full coastline? Okay. But we can add some more things like states or the Mississippi River, apparently. It's the only river by default. So like Ryan showed you this morning, we're going to add the country borders. We get the natural earth feature collection. Admin 1 states provinces. And we're going to add the feature collection. I use dotted lines and black edge color. Pick whichever you like. And then we call fig again so we can show the figure. And now we have a little bit better idea of where we are. We can see that things aren't flipped around. This image is going to be a little old because I started running this notebook this morning and had to rerun all the cells. If you've rerun all of yours, you'll have a slightly more updated image. So any questions on how we get to this point in the map so far? We still have some work to do because the color map is not like anything we're used to seeing. And we need to add some annotations on there, like what is the valid time of this? What channel are we looking at? Since it's GO 16, to make people happy, we need to say that this is experimental, not operational. So we'll get to all that. Mm-hmm.
Very briefly, for a non-meteorologist, what are we looking at?
So this is a mid-level water vapor channel on the satellite. Oh, it's high water vapor channel on the satellite. So you're looking at water vapor content
In the air.
in the air. And we use a color map that makes it a little bit more intuitive later. There's a standard water vapor color map.
That page that you had up earlier with the 16 different bands on it has some really good information about what you look for in all the different channels. So you can see them.
So, for example, I plotted channel 8.
If you click on that,
So we'll get this data sheet.
two-page README.
This is the color map that people are accustomed to looking at, and we'll apply that in just a little bit. Okay. So go ahead and get whatever sector, whatever channel you picked in the exercise notebook to a map that looks something like this. Yours will obviously differ slightly.
No, it's not. Should have tried it. Yep.
So we got the U8 and Cedar made in that CDF file. It has something in it.
I think we're generating those, but I'm not serving them because I don't feel.
You feel comfortable in
No, I haven't done anything with them.
So
I don't know. I'm glad you got.
It feels like a minor success. Like we finally got to CDF files and there's numbers in them.
You know, my problem at this point with those now,
Yeah.
the fact it's not that they were crapping out, the fact that people were getting time series with points from other stations, that bothers
That's
me.
sort of a deal breaker.
That's
Yes.
That should never happen.
So if
When you ask for a station, you should just get a station.
and it silently does. It's like, oh, just cold chills up my spine on that.
Somebody's gonna publish a paper on some crazy random event that's gonna be some bogus.
A heat burst that did not exist.
Even if they don't
Yeah.
publish it, you know, just someone lost time trying to figure out why is that weird point there.
Yeah, really
So we gotta,
work
Yeah.
to do.
as always, it never ends.
So there's a slightly more updated one. Looks basically the same. Also, I'm guessing somebody will, at some point, want to know what if they want to use a different ellipse. If you look at the doc string globe in Cartify, so it's going to default to WGS 84, but if you want to use NAD or whatever ellipse, you can plug it in there.
Isn't it construction?
Oh, in there, yeah.
It's transform.
Yeah, that's what it was. And then origin. That's if you don't specify the origin as upper.
Hmm?
That's if you don't specify the origin as upper. I think it's
There you go.
yeah, it looks nice.
Could I ask a question?
Mhm.
I have either I'm calling the important the color table, let us be in the wrong place or something is I get super
So those are from that's all units on a square grid.
Yeah, I think he just said.
Okay, so you can't just give it
Did he just do that? That was a
this
No,
string.
no.
The strings that are going to be there are ones that Matplotlib knows about, but the internal ones to
We're
Matplotlib.
changing the projection to.
So you have to use this.
Just regular.
You can use get color map or whatever.
Yeah, yeah, so sort of like this.
So you could say.
Yeah.
Let's first see if you use the registry get registry.get. Where's that function called?
Yeah, I'd say I play around with the extent.
Get tab.
So anything that was extending above that.
That was.
So then give that IRBD. And then either save the result of that call or just directly pass it to setC.
Okay, do folks have their map in some way, shape, or form? This is current CONUS. Yeah.
Oh.
Mhm.
So I made a change to remove the face color equals none.
Probably need that.
I'm trying to go back.
So we're holding on to the figure.
Oh, this figure's for you. Okay.
You have to run from the top to there. You can also set Z order and fill in the states, but put them behind. You probably have to run again. Z order sets like the layer, how deep in the layer it is. Okay. So everybody's got some form of map. Let's make it look a little bit nicer. So we're going to do some color tables and some annotations. Matplotlib is behind Cartipy, and the color mapping is handled through two different ways. So the color map converts whatever values you give it. So you've got this giant array in the range 0 to 1 into some color that's going to get plotted. But we can normalize our data through this norm function that controls how our whatever values we have in the array, 0 to 255 or floating point or whatever, get mapped into that range. So it's really useful to know what range of data we're dealing with. Is this is 0 to 255 that's coming off the satellite? Is it 0 to 1? If you've got some random temperature data, what does the distribution of your data look like? Where should you be putting the bounds of this color map? So I'm going to use Matplotlib's histogram function. So I get our data array right here, data var and an empty slice. Compressed means I'm going to throw out any NaN values, because we don't want to include NaN values when we're computing our histogram. And then flatten, we're going to take that 2D array and just make it one big, long, serialized, one-dimensional array. So what this will result in is no NaNs, 1D array, and we'll bin it into 255 bins. And that is the resulting histogram. So we see that we've got pretty much all of our data lying between 210 and 255 here. So there's no need to waste color space on 200 and below.
No need to, or there's no such data present?
There's no data present, and you would lose all of that range that you would get visually if you assigned the bottom of your color map to 0, the top to 255. You're going to have most of that color map taken up by 0 values, low values. So let's set the color map. So IM is our IM show object. I'm going to set it to grays And with matplotlib color maps, which if you Google matplotlib color maps, the first hit is this. You can take pretty much all of these, Ryan, _R.
Yeah.
Yeah. So the grays is going from light to dark. _R will flip it dark to light. So grays _R. This is setting the norm. So let me comment that out and let's see what that looks like first. You see here we have a relatively low contrast image. But if I go ahead and do my norm, in fact, I'm going to bump this up to be 210 to 255. Get a little bit of enhanced contrast down here now. If we set it 0 to 255, we see almost no contrast.
By the way, these values, again, that's the moisture upper, moisture down, 200 to 255.
So these are bit values coming, so it's 8-bit values coming down from the satellite.
What channel is this? 8?
8.
It's a brightness temperature, right? So it's the effective temperature that would be radiating at that frequency,
Is it actually the brightness temperature?
something like that.
It's not calibrated though, is it? What's coming down right now? And it's just the raw 8-bit
I'm looking
values.
at a visible image and it looks like calibrated reflections.
Okay.
Well,
Okay.
the visible, the 1 through 6 are one set of numbers.
Well, I
7 through
know
16
this
are
thing,
something
I
else.
don't think it's bits because the other channel came as a reflectance.
This,
So I don't think it's
Well,
like
when-
two
When we
fifty-five.
printed one line, the values went from like 230 to 265. So that looks like.
Let's see,
That
right?
looks like brightness temperature.
Okay.
I think the brightness temperatures for those.
It might be. We were used to working with GD files before, which are definitely
Bits.
bytes. So
Yeah, those were a 0 to 255 bit
Yeah.
value. Code 16 is different.
yeah, no, absolutely. It just so happens this happens to line up in that same.
Right.
The visible
vicinity.
does, yeah.
Well, so is these ones here.
Is that an index of another scientific measure
So
or
it's
it's
a
the measure
it's a
itself?
radiance, it's a radiance that's related to brightness temperature. So it's like,
So used 220, that's that.
yeah, so it's like 220 Kelvin. You're looking at, it has a brightness temperature at that level. I guess that means something. And how because quick that is kind of what those
So this is where we can learn from you all, because we are definitely not satellite data interpretation experts by any means. When I see something between 0 and 255, I automatically think that I'm dealing with an 8-bit ADC output.
So this is assuming 8-bit color. Can you do more than 8-bit?
Yes.
Yes.
Yes. Actually, this isn't doing any
There's no assumption in the color
The
map.
stuff I'm doing here, which is a little different than what you're doing, I've got a 2048 color table, or color table.
Mhm.
Because these images are actually, I think all this stuff is coming down as 12-bit
Yep.
values, so there's actually 4,000 different temperatures or brightness values.
But actually,
reflectance values.
in Matplotlib, you have all the knobs you want to turn there in terms of creating a segmented set of colors across a linear color space that'll interpolate across, and you can.
You can make it as big as you want.
Yep. So, and any one of these colors
So-
can be each RGB value can be a different 24-bit value.
Matplotlib color tables. Just Google. This is the first hit. Yeah. So here's some Matplotlib ones that are segmented. So there's the tab 20 colors.
Well, I mean, there's those, but also even these linear ones are defined by creating individual ranges of this color goes from this value to this value, so you should interpolate from here, and then we go to another color range that should be interpolated this, and so on. You can get into all the detail you could possibly want in terms of mapping colors here. And that's just handling the going from 0 to 1, not even the part of taking your actual data range and turning that into 0 to 1. You can do that linearly, you can do that logarithmically, you can do that binned up. There's
Right.
all the knobs you want.
So you should be able to see. Yeah, the doc strings are not incredible. But what Normalize is letting us do is right here, we're saying the bottom of our color table is 0, the top's 255. We get this not very exciting image. If we decrease the range, then we get this nice higher contrast image. So those are all of the, let's see, where'd our tab go? These are all of the stock color tables in Matplotlib. None of those are great for doing water vapor, not what we're used to looking at for water vapor. So in MetPy, this is the MetPy doc page that we've looked at a couple times now. If we go to the MetPy API, see down here, metpy.plots.ctables. And these are custom color tables that are included with MetPy. So you've got web service activity color table, velocity color table, several that we're familiar with, IR. But here is water vapor sims. I believe this is a direct adaptation of
It's from Genpack.
Genpack color tables, yeah. Hence the large bar of black down here. So we want to use that color table on this data. So we're going to import from the metpy.plots.ctables, we're going to import the color table registry, which is where all of these live. And if you list the registry, we see all those that we just saw on the website. The website's nice since you get the visual depiction of the bar. You actually know what you're getting. But if you're familiar with it, here we can see that's the color table that we want to use. We take care of getting the color table and assigning the appropriate range and norm with this registry.getWithRange method. So we say we want to get WV sims. We want to range from 170 to 255 in this case. The reason that I'm not ranging from 210 to 255 like we did before is remember that big bar of black down at the bottom? I want to cut that. I want to have to lower my lower bound. So otherwise, everything is artificially skewed. Then we set the color map. So im.setCmap, just like we did before. We set the norm to the norm that's returned by that function. And we get.
This worked a whole lot better when we were using the Gini data that were 0 to 55 than the brightness temps, because now it's kind of inverted from how you're used to looking at those,
Right.
those images.
Yeah, the color table maybe has to go backwards.
Well, I'm gonna steal one from AOS apparently.
I've got a few that I can share with you too that I use for the stuff I know.
Okay. Unlike Matplotlib, the _R method does not work on MetPy color tables. Okay, last thing is let's add some annotations. So in the data set, metadata, let's just print the data set so we can see this. There's this start, date, time metadata attribute. And everybody here, I'm sure, is eminently familiar with this format likely. So 2017, then the Julian day, and then I believe this is hour, minute, second when it arrives. Yeah.
Hour, minute, second of when the scan started, I think.
Okay. So there's that string. And now we need to solve the reverse problem of what we did this morning. This morning we had a date time object and we wanted to make a string out of it. Now we have a string and we want to convert that into a date time object that we can do math on, we can do whatever we want to do with it. So we're going to use this function instead of strf time, it's strp time.
String parse time.
We pass it the string, so this right here, and then the format. So we have year, Julian day, hour, minute, second. Let's run that and print out the timestamp. We see that it's parsed correctly. That is indeed today and about 20 minutes ago when I ran this and grabbed the data. Okay, so here I've duplicated some of the code that we have above so we can see everything in one cell. But this should all look familiar. We're making our figure, axis, IM show, coastlines, boundaries, and borders. It's everything that we had above. But now we've got some extras here. So I'm going to use ax.text to put text on the axis. I want to put my timestamp, and now I need to take that date time object and take it back to a string. But I don't want to print out the string with Julian day because that doesn't make sense to most people looking at it, right? Date 157 doesn't mean a lot. So we can print it whatever format we wish, really. Here I picked a nice custom formatter that is a preview, gives you the day, the month name, and the year. So B is full month name, day, year, hour, minute, and then Z. Say that I want the horizontal alignment, so I want this to be right aligned to these coordinates on my figure. These are relative coordinates, 0 to 1. So 0 to 1 height, 0 to 1 left to right. So I want it to be at the far right side of my figure, towards the bottom. Right align the text to that coordinate. This transform tells us that I want to use that relative axis transform. I want the text to be white. I want it to be extra large. You could specify a font size here if you wished. Extra large works well. And I want it to be bold and weight. I'm also going to add some text that says this is experimental, go 16. And then I could hard code a channel here. I'm using channel 8, but we should make this versatile. So I want it to be channel and then insert whichever channel I declared way up at the top of this notebook. Here I want to center align it. So my X is 0.5, put the center of the text there. Puts it right in the center of the figure and puts it almost all the way to the top. If you just run that, what you're going to end up with is white text on, in this case, some white background, and it'll disappear. Notice how we've got this nice black outline that helps the text pop out. That's done with a path effect in matplotlib. So we import path effects from matplotlib. In this case, I go ahead and define, since I'm going to use this effect more than once, I define it as outline effect. And I say that I want to have a 2 width stroke around the text that has a black foreground color. Then I just have to call set path effects on those 2 text objects and give it outline effect. So now if I were to change this to a different color, you see the outline changes to blue. And it did it for both. That's the advantage of defining it in one spot. You don't have to type blue twice. Any questions on how to use a color map or how to put text with some effects on your plot? No? Okay. Try to dress up your satellite image a little bit. So put some text on it, pick a color map that you like, and break some things. We will come around and help you. Take about 10 minutes to do this or so, and then we'll go on and do some bonus material.
I just
Yeah.
use it. But we would just listen to range. This is regional. It's the traditional one. You may not have to.
It's all right.
Let me see, because then you've got to do it in projected coordinates, which you don't want to do in projected coordinates, really.
I should probably first just figure this out.
Is there a quick way to do, so right now, like if you want to crop your image, you have to set the extent projected coordinates.
You can pass transform to set extent. I think it's transform. Yes.
The whole 0 to 255.
So if you do that, then you can say plot 3 and give it lat line.
The whole 0 to 255 taking the images for the visible that represented the reflectance value 0 to 1. For the IR values, there was a function, it was a two-section function where it goes by half of each big value 0, 1, 2, 3, 4. It goes by, I think it's full degrees from like 330 up to 255 or something like that. And then from 255 up to 160, it goes in half degrees. I've got a paper that defines the
Is
equation.
that fixed? Because like there's a Python library out there that will go get you a like, historical database of the calibration values over time.
That may have changed over time, but those are the ones that I was using. And as far as I could tell, all of the color maps that I found went from 0 to 255, assuming values were set from like the temperature, brightness temperature 160 to a brightness temperature of 330, using that scale where it's like 1 degree and then half degrees. And so I spent a lot of time screwing around making those.
Spent time looking and being disappointed that the Genie imagery coming over the report didn't have the calibration information in the header. So at this point, Genie goes away in probably another 3 years.
Yeah.
So
If I can find it, I'll shoot you a link to the page that was talked about it. I think that's what it is, where you go to convert from a brightness or from a reflectance value to a brightness temperature, where it's like 1 degree for part of it and half degree for the rest.
Yeah, bilinear expression.
Right, okay. That was how I came up with the 162 to 330, where the temperature range. Or 162 and a half, it might be.
we need some better way within there to like do
this on.
physically ranged color maps.
But see, depending on what channel you're looking at, all of them have that sort of range assumed, but you're only using sections of it.
Sure.
And with the 12-bit imagery, it doesn't really matter because you've got amazing resolution no matter what. That was why I ended up doing my own.
It's weird because Tim's been playing out around this question that was for the 8-bit, really sitting at the 8-bit.
Right.
Range and somehow we're used to it.
Right. Well, and so I took color maps that were in that 8-bit range and just
No.
over that. I think I've got a
Set extent.
Like 2048 color maps right now that
Plot the image as it really is, because that's your only X and Y values. You need a separate call to ax.set
but
extent.
stretched over the longer, just.
So we don't need to extend call at all then.
Well, no, you do need one because that's how you're georeferencing.
No, that's exactly it, because that's kind of what we had to do with
Yeah.
Yep.
But now you use this set extent like we usually do to set the drawing range.
Okay, so there's
Source set extent.
and let's see, I'm gonna grab the full CONUS values.
Now, yeah. That's I forgot we're working with Dynamo show, so extent means something. Oh, come on. What is CRS? It's something. Shift tab. CRS. My bad. There, Michael.
That is horribly inconsistent.
What?
That's horribly inconsistent with
Well,
everything.
I mean, I know why, but they should have gone for consistency there.
What's not consistent?
That the argument parameter name there is CRS rather than transform. I don't control it, I just teach it.
Only partially true, you are a Matplotlib developer.
That set extent's not a Matplotlib function, that's Cartopy. Set extent does not exist for Matplotlib itself. It's set xlim and set ylim. There's special handling with set extent for the
I got a question.
geo math and stuff.
It's boilerplate. I didn't-
It just sounds so starting. You know, I'm probably it's just a boilerplate, but it's just
Just check the other one.
it kind of surprises me.
Just don't know.
You can rerun your data.
This one's a difference for 2 hours.
Tell your data shows.
I gotta change it. It's an hour.
Nope. And what you
Does that
said.
mean in your mind is this the department? Because this, let me see, this is mine.
That's a typo.
Okay.
Unless what hours are some better.
Why don't you just call the color bar function, you don't need to have to save the results of all the things. That's only you need to handle the set of the properties. Otherwise, you can call color bar. And it'll
Apparently we did, but Matt's not available. I had no idea. I thought we had one last week.
No, it's.
That's 2 weeks.
I mean, like I had an alarm.
My first one up was linear, just one, reference to weight. And it was really cool, the contrast you, and you can see details of the types of clouds that you
Which part of the color has a
show
little light?
details of them as it gets towards dawn or dark, it's real dark on the ground. It asked me about the square.
The problem with the black area is just that's those are the colors that are coded in. We need a better version. Especially when it works.
But then like splitting it up.
Flip the right way. As far as controlling the size.
So you've seen my stuff, right?
Yes, I've seen your stuff.
So so the visible and the linear. There's a one.
Oh, is this your tab in there?
Sorry.
There's just all sorts of these things. And so that's not giving you a whole lot of. If you expand it, next time you can expand that, there might be.
So see, I've got the
Wow,
two.
there we go.
That's the square root. It shows the ground, so if you go to like, this Wisconsin area.
I hate Rogan.
Yeah.
It's got the knob, the man, it's.
One is darker, but I can see where you did it not like sometimes.
What's the problem? Yeah.
Yeah, so I've got them both up there.
It's like asking you to make a grunt.
Question is,
Then you can see, you know, so it's better.
right, but then it's one. But it is so my, whole thing with the one. It's not, it's not about
They're there because what it does is it steals the space from the axis. The figure shrinks it and builds it in another axis. Colormap on however, crazy it shrinks.
When you move it, you can see the different layers.
You can eventually get there.
It feels. Still, it looks like some arcade versus the second.
No problem with that.
John, you can have the whole
No,
thing, the
this
whole
is live tweet,
can
it's
model
live
stuff.
Bible or something.
Just a dumb way to keep it. So like,
No, you think of it as you're showing them what they need to enable that. Here's the data. Here's the data access expert.
You guys figure out something to combine those two or works better. It's almost like use the square root up to a certain range, so there's linear somehow.
Well, that's
And there's
what we got out of Genie. It's 0 to 255.
Hardware conditioning, hardwired,
Yep.
anything that's power of 2.
Yep. We have got to get a better color table. That's driving me insane.
Is it flipped?
But you can't just flip it because of all that black stuff. Because I stole it from Jetpack.
Yeah. Yeah.
If you bring up your, go look at your the examples that are in the GOES 16 doc. Bring up the PDF.
Wait a minute. Dries.
Oh, go back to it. It's not. I've looked at it before and thought it was. So
And it's also the one that
I can't tell.
So that's saying that's all moisture and that's all dry.
I'm not sure if I believe it or not. That doesn't look right. That looks like that should be dry. That should be moist. Because that's turbulent and that's.
What's the correct visible?
Or I could run the same code with the Genie file.
Yeah, I don't know. They're just a mix of values.
right, because, well, that's
But there's no, I don't think there's anything saying set to 0 because it's bad data, not because it's flat. I don't think there's any sort of that.
Good enough.
right, well. see,
So that's cloud.
yeah, it has
So they are flipped.
Yep.
yeah.
Well, what if you did this? What if we were naive about it?
But so you could-
What are you gonna do?
Something is likely naive.
Is that easy?
See, so I have to change all. Yeah, I don't want to change all the norm and all that.
No.
No, that is ugly.
Be a time to move on.
What is the break time that we have in the schedule?
Hunter was talking to me, I guess, with Lotus, they've got some band and stuff where they look
3.
for, like,
3.
Although we started 15 minutes early, so
like, what are the differences in the versus some other?
I'll do the
And he thought you might do
animation and then I'll just show them the animation and then break for 10
and then what?
well, because the
RGB.
Yeah, but it was a combination of,
and one other one out.
yeah. That'd be good.
I think it's
Okay, so it sounds like folks are mostly happy with their plots. Want to show you as some bonus content how to do an animation. This will probably, if you have a Windows machine, this will definitely not work out of the box. If you're on a Mac or Linux machine and you've got FFmpeg, it will work for you. You can also use this command that we have down here at your Conda terminal to install FFmpeg if you'd like. But on Windows, I have yet to see somebody get it easily, successfully working on Windows. So we're going to use Matplotlib's animation utilities
which we happen to have the expert in the room because Ryan wrote it, and it's a very, very handy utility. So we're going to import the artist animation class from that, going to use HTML display for the IPython notebook, and import a few other various like os.path and sys modules that we're going to use. We go ahead and make our base map. So we make a figure object, add a plot with projection, coastlines, state and country boundaries. You see we get this nice entire world projection here. Now we have to build a loop that's going to go over the last however many images or however many frames we want in this animation and create a collection of the artists that draw that particular frame. And we make a list of those. So here I'm going to make an empty list called artists. It's going to hold each frame. I'm going to go ahead and I added the capability to downsample. So if you're plotting CONUS or full disk, whatever, you're going to want to downsample that some. Otherwise, this is going to take a long time to render. Here, I'm just going to downsample by 2. And update that comment because since I'm not doing CONUS, now I'm looping over the last 60 images in the catalog. So remember, we have that catalog from threads. Here I'm saying get me the 60 most recent items out of that catalog. So start at the end, go back 60. And I'm going to loop over each of those and call them DS. So here I open the data set. It's opened app, just like we've done before. Get the X and Y timestamp and the actual data. We're pulling those out of that CDS file. Exactly what we've done. And the plotting is literally a copy and paste of making one image. We're just doing it over and over again. Lots of them. But the last line of the loop, we make a tuple. So the image and the 2 text items that we've plotted, we group those artists together and we append those to the list. So we have a list of this tuple. So we'll have 60 items in the list, 1 for each frame. And then outside of the loop, once we've built up that list with every frame, we use artist animation to tell what figure we want to plot on. We pass it our list of artists, the interval, so how long to dwell on each frame, and whether we want to use blitting or not. So a way that the image is posted to the screen, I think it has to do with whether it's posted, force posted or not.
If you don't blit, it's going to redraw everything. If you blit, that's a graphics term for you take this saved copy of an image that represents the background, which would be all the matplotlib axes and whatnot, and then you blit. You do a quick copy of other image data on top of that. So it can be much more quick, but it can also be a little finicky.
Is it an acronym for something?
I don't think so. I think it's a 1980s graphics term.
And then we use HTML, which is from up here where we imported IPython.display, HTML. This allows us to display an HTML5 video in the notebook. So you could save this as a video output format. You can save the individual frames and make a GIF. You can do whatever you want with these. But you see now we've got a moving image, and we have the HTML5 control bar down here, so you can move back and forth and all that.
Are you able to add a color card to this animation?
Yes.
And it's not
Our,
of the brightness. So
Yeah.
you have the original.
yeah, so let me go back up here, do a color bar on one image, so we don't have to re-render everything. Now, this is where we hit having that big chunk of black colors. There are ways to trim that down they're not pretty ways. Unfortunately.
The better answer is to make a better color bar that doesn't have all the black
Yeah.
useless area. So.
But that's how you do it, just the color bar method. Okay, everybody good so far?
No.
Did you install FFmpeg?
This one.
Try running that one.
So do I just copy that into the command line, even though I'm already in?
The animation will.
We'll come back and help you in just a second.
This one shows.
Okay, so we're gonna take a 10-minute break,
You will see.
and then we'll come back and we'll learn how to stack multiple channels to make false color RGB images.
Could you repeat this color bar thing? Just go up. Thank you.
And then just run it in here, even though I'm
All
already.
these are right in here. Right in there.
Good enough.
And then I'll overlay the full resolution.
Alright.
Hopefully.
Okay.
Really?
Well,
I'm on a Mac.
Should work on both, and actually,
Trying to scale it. I did actually a 4 panels like this. The low, medium,
Do you have
low
light?
water vapor. You can traditional IR, I'll base it on one thing. And then run different axes. Color bar. Yeah, but it's cool. It's a cool looking.
yeah, the animation just gets, you gotta do more, you don't wanna end up with 60 different color bar calls.
Yeah.
That'll screw things up, so you gotta work on some more complex control flow. to get
Any
that
of my animation stuff, I'm just rendering the images on a cron tab and displaying cons.
And you know, that's probably more efficient.
It's less interactive.
So it's not great.
Yeah. Well, I mean, this is interactive in the sense you can change it on the fly, but it's not in the sense you have to wait a while for it to.
Yes.
Yeah.
Hopefully in the next rev with Matplotlib, I'll have in, somebody wrote a package to do, like in a notebook, use JavaScript and just display the images. You know,
Yeah.
and hopefully we'll get that merged into Matplotlib, so that'll be baked in as another option. Because getting the right codecs and the right incantation to embed the movie in there and have it play in the notebook can be really finicky.
Yeah. Maybe on Thursday, I can show you the scripts that I've got working with the color bars and what I've
Yeah.
learned about
Sure.
it. If you want some of my color tables that I've got, probably would have saved me a lot of time if I knew that MetPy had color tables in them, because I spent a lot of time on that. Going out, searching for them on the internet, finding what colors they or what brightness temperatures they applied to.
That's the tricky part.
Yeah.
And I don't.
And then mapping it to what we have. So
I
all
just
my
kind of fudged it for the Genie data, and now, okay.
yeah, it's we can make it right.
I also think it'd be nice to just take these and have them available, like the rest of the block color tables.
So you're right.
Hey, you just passed the string name to the block.
Still running.
Still right. Yeah, it may take some time.
Feels
honest.
If you close, it's gonna
Yeah,
take
that's
more.
gonna.
But
What's the release report you guys using? Well, what you want to put it in, I went into the loop, breaking down. So then you can't read you see where you have, oh yeah. You have 60 frames.
That's fine.
So stretch, what I did minus 60 colon.
All right.
And then do like 10. So sketch every 10.
Oh, you don't have the extender? That's right.
No, it's a separate accessory and
Cheap.
Then interrupt that. Start.
apparently one that we cannot.
Don't even get me started. So,
Because I was at 20%.
oh, yeah.
It was about to
So
hurt.
will you charge my phone while you're on battery?
Well, you can plug in here.
GFDL being shut down.
Is there coffee over there?
GFDL shutting down July 5th.
What?
The model, they're shutting it down.
The Hurricane one?
The GFDL model, yeah.
What's gonna replace the H1?
HMON. new NOAA environmental modeling system based hurricane model called HMOD. Hurricanes in a multi-scale ocean coupled non-hydrostatic. And I thought programmers were bad at naming things. Sure.
I noticed this values right here in the stems are
Yeah.
Previously they were just close parentheses or empty parentheses. I was wondering why that was.
RULZ.
Right.
Oh, okay. So there, that's asking to call the min method.
There is
the
a
max
top method
method
on
on
T and
the array.
treats over there. So
Okay,
you
that's-
get straight to
If you go down, we're actually indexing it.
Or we go in for the
Basically getting the first and the last.
It's already, so just get started.
So this is asking it to calculate what its minimum value and maximum values are. Okay. So that searches through the array. We probably should add that to the list. One place we do min max for the extents, and another place we do 0 and -1.
All over from the Genie stuff.
That is, there we go.
Okay, thanks.
Improvements for satellite.
No, the biggest issue with those images were not really helping Google. The biggest issue was how to pronounce the spell guns. Yeah, sorry.
Is that the easy one?
Yeah. Why is it black all around it?
I mean, was it black all around?
I think I am showcasing it.
Interesting values. Wireless white?
Yeah.
Yeah.
Ah, here you're color mapping it. The top of the color bar is white. We're not color mapping on the other one. You're setting the RGB values.
Okay.
There is no color mapping, only zoom. It's reached that time of day.
So you can use IM show, but can't you just also use contour F? Doesn't that kind of do the same thing?
With a fine enough contour value, you could.
Okay.
It would be
For
horrible
satellite data,
slow.
that sounds like an abomination. Okay. I've done it on model output to get really nice looking things where P-color match is slow, but I still can't understand why contouring and drawing small contours is faster than drawing quads, but it is. But for image data, where you're just drawing a big quadrilateral and saying, here are the corner points, and then splat this image there. That's going to be the most efficient way. Yeah. And what you'll see when we do the RGB imagery in a second, that's the only way you can do it for the false color.
Okay. So I was thinking, like, the most common use case I would have for displaying satellite data is I would just work with like the raw stuff that usually comes with like its own lat long map. So I see like here it's like you set up whatever projection you want, but then as long as you use that like array thing, I mean that's the proper way to do it, I guess, right?
Yeah, and if you've got lat long fixed projection, essentially,
then your
X and Y are that's why I mean this sounds stupid, but when you ask me what correct projection it's in, I don't know. I just have a file that gives me the geolocated lat long for each.
If you've got that, then plot 3 is probably the right one.
Yeah. Okay. I mean, is that stuff you've ever dealt with, or is it pretty much always?
The closest we've got is sounds close to the full disk stuff.
Maybe. I mean, I don't use GOES much. It's usually like
a
sounder product.
Oh, okay. Okay.
For the LEO orbiter,
Yeah.
or like any other sensor. Like I often the fundamental thing is an array of radiances and then the geolocated.
Then in that case, I think if you've got lat longs, plot 3 is the way to go.
I mean, if it becomes like often really hard to do it efficiently because you have to like, to do it accurately, you have to draw the individual polygons. Is this something you've ever had?
That's
to deal with?
possible. That's where you want to use P-color mesh.
Okay.
I will say, well, I guess if you've got lat lines, it might not be too bad. Sometimes doing the reprojection in combination with P-color mesh can get slow, pretty slow.
I mean, it's probably CartoPy is no worse than base map, or maybe better.
Correct.
Pushing it, but yes, no worries.
I wouldn't think it would be. P-color mesh and that part is just slow. As a radar guy, same kind of problem, except it's trapezoidal quads on a polar thing. It's just, it has never been fast enough for my liking to do like interactive.
Well, no, actually, that's like exactly the same thing.
So
right? Because you want to do
P-color
it correctly, you have to draw arbitrary things.
And so you can make a mesh of those. You know, where you like have.
Well, is that the way you use it, or you're?
Technically, the way you should be using it is you have your values here, like a 2x3 array of values. You should technically have.
Well,
technically speaking, you should have it like that. If you don't, P-color mesh will do this. And then when it goes once and
but
or no, excuse me, it'll no, that's right. It will make it that way.
Yeah, right. It's normally when you have 1,000 by 1,000 characters.
Exactly.
One.
But that's what it wants. Is you have.
Well, but if you,
but
I'm
you
just
can actually
curious for your case, if you have radar data and you have a cell that really looks like
exactly. Yep.
How do you do that?
So you end up you have two different.
I mean, you have to like define the vertices or something. But you would do that with it's still P-color mesh.
Yeah. You can do two separate 2D arrays of X and Y, where each pair X and Y defines one corner point.
Well, it's worse like for for like the sounder, like Chris, the footprints are actually.
Okay, well that's.
So to draw it. Anyway, you have to loop over the point.
You would for that. There's no way to express it in P-color mesh.
That's a pain.
That's terrible.
Yeah, so I don't. Just very roughly, what's the schedule for the last day? I mean, you just show up at 9.
We're talking about AOS. We're talking about the hack day. Show up nominally at 9. Is there something you want to work on, or we'll talk about more informally various different things, whatever people are interested in. Maybe GitHub and doing stuff with MetPy. Maybe tips on trying to apply this problem.
I won't be here tomorrow.
Okay.
I just want to come back for that.
Nominally about 9 o'clock on Thursday. Yeah.
Okay. All right. Thanks.
Start at the quarter till.
By my watch, it's 46.
By that clock.
Okay.
The one I've been going off of.
Gotcha. Not that I care. I'm off right now. At the moment.
I was like, this going through the RDP is not going to take very long because it's.
Oh, just wait. I said we're going to get questions. And it's the notebook. They have the notebook, right?
They have the notebook. I have them running. There's no exercise with it because we normally don't show.
You can ask and see if they want to play with that. I mean, honestly, I'm in a room full of satellite people. If there's people interested, if enough people are interested, let's do it.
So we'll just do minus.
I will run to the head and be right back.
-2 colon.
Minus 2 colon.
Oh, did he use extra colon? Oh, yeah.
So
it
it
is.
shows that the belts place.
This is your MacBook Pro, so it's 4 years old.
4 years old? I was just asking.
5 years, so you got it. 2012, 5 years.
I shouldn't say option. Yeah, it's one of those,
Did you feel disappointed?
but- is showing what Michelle's mother was doing wrong. And I think someone's even asked Wayne if Michelle was his wife.
Oh, yeah, that one, that's. I mean, granted, I've taken classes.
Yeah, so you know.
Yeah. Yeah.
I mean, what? All right, that's good. That in here. Francis Ford Coppola left the building. That's.
Okay, so it looks like pretty much everybody's back and caffeinated. So we're going to do some extra satellite things that we normally don't go into. They're normally just included as bonus content. We say, go look at these things. They're interesting. But we figured that it's something you might like to see. I'm going to start off with using notebook widgets, which in Jupyter Notebooks, you can have widgets that are things like radio buttons, drop downs, check boxes, text fields, the traditional web form elements. And we can put those in a notebook to make what looks like almost a small app. So let me show you what the end result is. So here's our plot, which doesn't look anything exceptional. But you notice now I have some drop downs up here. So I can click this drop down. Here are the 16 channels. So let's say I want red band. So I click that, and we go out and get data, and there's red band replotted. So now I'm in mesoscale 1. Maybe I want to go to mesoscale 2. So I click the mesoscale 2 in the drop down, and we're getting data. Now our map is moved. You can see we're over a different sector. So using widgets, you can make little tools for data exploration. We're not going to have an activity on this, but I want to show you how it works. And I've written this a little bit more like the script would be, since we're not teaching directly from the notebook. So like I mentioned earlier, all my imports are now up here at the top. So you can see there's a lot. The widgets are coming from this MetPy widgets. And there are a few in here that we're actually not using, like float sliders. Now I've defined a couple of functions. First, I made a function to open a data set. You can see I put a doc string there. So that I remember, and you remember when you look back at this, what this does. It returns the netcdf dataset object for the given date, so date time object, the channel that you want, the index, so where, -1 being the end, most recent, 0 being the first, the oldest, and which region, mesoscale 1, 2, CONUS, or full disk. So this does nothing that we haven't seen before. It builds the thread's catalog URL, gets the data set, opens it as a netcdf object, and returns that to us. I also made a function that plots the map, because the way widgets work, when you interact with them, they're going to call some function, and then it'll return its output. So this takes the date, the index from the end, which channel and region we're interested in. It calls the open dataset function that we just looked at to go get the data. Pulls out X, Y, and Z, or the data. Our familiar projection variable, creating our globe and projection with Cartipy. This is all just copy and paste of what we just did. State boundaries. We make our figure, add the coastlines, boundaries, borders. this is a little bit, this is the one new piece in here really, is if there are any images on the axes object, we want to remove those. We don't want to be plotting image on top of image on top of image on top of image as we keep selecting different channels to look at. After you get to about, I think it's 20 of those stacked up somewhere in there, there's going to be a warning come up that says you're stacking a lot of data on this figure and it's getting very large.
And if you don't stop, then the kernel will eventually just crash.
Yes.
Because you're out of memory.
It will get slower and slower and then die. So here's our IAMShow command. We're putting the data on. We're adding our text annotations, our path effects, and then we explicitly say that we want to display the figure in the notebook. And we close the reference to the plot. Down here's where the widget magic actually happens. I made a dictionary. So Ryan told you yesterday, dictionaries are one of the prevalent data structures in Python. So I have a dictionary where the key is the easy to read name of the channel. So what you'll see in the dropdown, and the value is just integer channel number. So for example, if I removed 1 through 16 out here and just left blue, red, veggie, etc., the channel number is still stored there. Here's where we make the channel dropdown. So we call the dropdown function. We say the options come from this channel list. We set a default value, so 9 in this case, which would be mid-level water vapor. And then the description, which appears out here, channel. For the region, there are only 3 of them that I put as options here. So I didn't bother making a separate list outside. Just call the select widget, say these are the 3 options, send them back as strings, and we're going to call it region. I'm calling the most recent date, and I'm fixing the index at the one before the most recent. You could add a slider here if you wanted, so you could slide through time. As you see, it takes a little bit to go out and get the data and plot it, though. So it's not going to be a very dynamic slider. That's why I did not implement it. But then we just use this interact function and say, we're going to call this function plot those 16 channel. Its date argument is going to be fixed to UTC now. The index is going to be fixed to -2. Channel comes from this channel widget. Region comes from the region widget. And when you run that cell, you get your interactive toy there. Ah, yes, there's some maxed out.
Yeah.
So this is a bug that is, I'm told, going to be addressed relatively soon, where if channels are maxed out, they show up as zeros. So we see that pepper color here.
I guess it's a general question about developer. Do you know, normally in the data there's a variable that holds the wavelength of the channel. Is that not come over across no parts?
Yeah, that's in there somewhere.
Should
In
be
fact, I
as
think we're putting in the file name.
We are putting it in the file name.
Okay. I mean, I guess that would be as far as annotation more important than annotation.
In the channel.
Okay, yeah.
Fair enough.
So that could be, we can modify and add that.
Or yeah, you could just add it to your dictionary somehow, right?
Mm-hmm.
Okay.
Sure.
Yeah, so you could put it there. You could even, you should be able to get fancy. This would be slightly risky trying this live, but see if that, no, it doesn't render.
That only works for Matplotlib.
Yeah, so I was trying to use some tech to render microns in there. And
You could use the Unicode character for mu, but I couldn't tell you what that is off the top of my head.
yeah, so that's a good suggestion to actually put the wavelength in there. We'll do that. Any questions on how? There is a notebook that you've got. I believe it's in the Jupyter Notebooks directory that we went through yesterday morning. That's got a bunch of examples of how to use interact. So for example, there's you've got a matplotlib plot, and there's some sliders where you can change amplitude and frequency of sine wave, and you can watch the plot dynamically update. So if you want to build these little analysis tool app looking things, interactive widgets are a great way to do it. Okay, the other piece of bonus material before I quit cutting into Ryan's model plotting time. If you go back into the main notebooks directory, there's Go's RGB demo folder. Go ahead and open that. And open the bottom one here. So Go's RGB, or excuse me, the top one, Go's false color RGB image. So here we're going to take 3 channels from the satellite, assign one to red, one to green, one to blue, and make a false color image. Before you start playing with this too much, I'm going to warn you, this particular notebook assumes that those channels, the data has the identical shape, which is not the case for all the channels coming down from Go 16. So you have to have channels that are at the same resolution. So looking through here, again, we've got our slew of imports at the top: Siphon, netcdf, matplotlib, cartipy, numpy, datetime. Defined an open dataset function, should look familiar, what we just looked at. Here we specify the date, the channel, and the index. And it returns the netcdf object. And then there's this function, make RGB data. So what we do here, take the date and index, so -1 being the end, 0 being the oldest. And I have hard-coded in here what I want for the red, green, and blue channels, because I know these are all at the same resolution. There are definitely people in this room more qualified to say if this combination of channels and a false color image is scientifically useful. This is how you would do it. Then I open the netcdf datasets, so red, blue, and green dataset, calling my open dataset function. Again, this is a great place to see this is why you would functionalize something. You don't have to keep copying and pasting big blocks of code. I get the data as arrays. So dot variables, sectorize CMI, and my empty slice. Then I call this function numpy.dstack. So let's pull up the doc string for it. So it's going to stack the arrays depth-wise. So I'm giving it are 3 two-dimensional arrays, and it's going to stack those. So now I have 3 two-dimensional arrays lined up, one behind the other, along the third axis. So I give it a list of the 3 arrays, red, green, and blue, in that order. For that reason, that's how matplotlib is later going to interpret it. I pull out the X and Y coordinates. Here, I'm pulling it out of red. I can do that because I'm assuming that these are all 3 at the same resolution, same projection, and so on. I get the projection variable, time, all of that, just like what we've done before. And I return timestamp, X, Y, projection variable, and the data. Okay, so let me make sure that we're running that cell. Okay, so I'm going to use UTC now, get the most recent, pass that date, -2 to my make RGB data function, and catch the returns as timestamp, XY, projection, RGB data. And this block of code is literally a copy paste from what we did with one single channel. You look at the IM show. Was it? Why did I slice it? Good question. I'm passing my RGB data, an extent. When I run it, this is the false color image that comes out. So we stack those 3 channels, and IMShow is smart enough to know that when it sees an array come in with 3 dimensions, that 3rd dimension is going to be red, green, and blue. If you try to pass more than that in, it's going to cry more or less.
I think it also accepts 4 dimensions if you wanted to have an alpha channel separately too.
And you can see some of the strange pixel coloring here from that different channels maxing out, and that coming across as zeros in the data right now. Okay, so any questions on how RGB along a 3rd axis works? I'm going to show you one last notebook, and then we're going to turn you loose to play with doing RGB composites and breaking things and telling us what we need to be making easier with MetPy. So there's this Goes RGB image notebook, not the false color that we were just looking at. It is very, very similar. We have the same open dataset function. We have a make RGB data function that looks almost identical, with the exception that the red channel is at a different resolution. So it's coming down at, I think, roughly twice the resolution of the other 2. So we need to do some interpolation. So I've written this interpolate red channel function. So it takes the red dataset object and it's going to interpolate it to the same coordinates as this resampled dataset object has. We do this using SciPy's interpolate 2D function. Let me run the import up here and we'll pull up its doc string. So it takes X and Y. So we're going to interpolate over 2D grid. These are the data point coordinates. And the Z value, you tell it what kind of interpolation you want to do. Linear is going to be fine here unless somebody says that's not a good idea. And it's going to return us the data set. Or excuse me, it's going to return us a interpolation function that I just call F here. And to interpolate the data, I call that interpolation function and say, I want you to interpolate the red channel to these new coordinates, X new and Y new, which will match the green and blue channels here. So after we interpolate the red channel, it's returned as red data. Everything else works exactly the same because now we have red, green, and blue channels that are all the same shape. So we can stack them with dstack and get this image. See, we've got some more of that discoloration. And everything looks very green because there's no true green channel. This is veggie band, and we do not have a calibration table to try to get this to look like a true color RGB image.
So you're interpolating inputs, is that it? Because I think actually the 2 options that they're doing right now are nearest neighbor or averaging. But so how would I average? Is there a similar approach to average, or do I have to actually kind of?
Is it? See if it's in the doc string here.
Well, I don't think it has it, but you could write it as a quick function or quick slice. So
you could write a way to do the averaging.
Yeah.
Okay, would I be
yourself.
averaging like by running through the grid itself?
You wouldn't have to run through it. You could use some creative slicing.
Okay.
And, add the 2. Basically, you're going to have 2 different views of the array that you're adding together and divided by 2. Or maybe 4.
Around, doing a current around.
Doing the around.
Like like the half kilometer is within the 1 kilometer.
Yeah, I got you. It still sounds like 4, but
Yeah, it's 4.
yeah. So you could use slicing to get those 4 ones aligned up. Essentially, you'd be basically moving a big subset across that array and adding them together and dividing by 4.
So shifted one,
Right.
one.
Here, let me right there. I'm not going to pretend this is going to work exactly, but what you're looking at is if we had red as your red channel. So with all those slices, you're kind of saying, okay, let me do one that's all up to the last point in each dimension, one that we move over and start one shifted over and go to the end. Do another one that moves a row down and goes to the end. Do another that's shifted one off of each dimension. That's kind of how you can do these things. Like same kind of thing works for doing finite differencing. All these are, that's how you write that in vectorized notation rather than doing loop, and that will be a lot faster than doing the loop manually. And the nice thing about that is also no copies are involved. By doing the slicing like that, it's just returning a shallow view of the underlying data. So it's very efficient.
And there might be some of the imaging processing utilities that do this.
Yeah, that's a whole other thing. If you're doing lots of this stuff, scikit image, SK image, is a library that has a lot of functionality in terms of image processing algorithms implemented in Python. And I think implemented in C underlying it to be very fast. So
you can
beyond doing something like this, I would start looking at those kind of things for more advanced image processing type functions.
I would probably even look at it for that because there's all kinds of filtering and
yeah, there is a lot of filtering in there.
Yes, so because anytime I'm writing something like that, I think there's got to be an implementation that somebody did.
Someone better at it than I am.
Right. So there's scikit images page. They've got lots of examples as well in their gallery. Okay, so we're going to let you play with for as long as you would like to, let's say about 10, 15 minutes, with using some different channels to make false color RGB images or play with the interpolation. And we will come around, get stuck somewhere, put a red sticky up.
I got a best idea.
All right. See ya.
Right.
Oh, as far as.
Right.
His research is making green bean.
Okay.
He gave me a first order approximation.
Fantastic.
Sounds like a good section word.
Okay. Let's see. Also not sure why I'm slicing there. Oh, it's you have to flip.
That wasn't the one. That was the problem. There's another part in here we did the interpolation you flipped twice.
No, I'm hitting there though.
Okay.
I was trying to figure out why this was, but you have to flip.
Taking the average is a better idea.
You can't just assume any value.
Let's see. So we want 0. Except I'm not doing red. I'm doing green.
I was gonna say.
Right. You're not going to say the combination gives you a close. But if you have a missing term in the point that says 0, the combination of hundreds and 0 might be make something less than.
Yeah, which is what might be happening here.
They look pretty good. It's hard because it's low sun angle and late.
Yeah.
Let's move to a different.
Mesoscale 2. It's in the URL up there.
Oh no, it's a call somewhere down, I think.
Nope, it's in the URL up there. Keep going. I saw it. Keep going.
Did I hard code
Right there. Yep.
Yeah.
I'm using you only take 10% of the vegetation panel there.
Mm-hmm.
Did that actually?
Yeah. That's right.
So there are additional corrections to do, but that was
Sure.
the simple linear combination.
Oh, it looks a little brown.
Yeah, if you look on here, it's
And look at the screen over here.
well, but it's much clearer.
Yeah. Okay, now we're talking.
If you think about it, this average may take a while.
So what are you doing? Models? Yeah. Not even worried.
I think the connection tools be missed.
My brick somewhere over there. Or on the floor.
Yeah. I'll flip it.
I'm at 40.
Every time you kind of get to that, and you do stuff, but at this point, it's a little bit tweaking in CSS syntax, some different plot methods. It's not a lot of fundamental new stuff, which is good at 320. But you're contouring and that kind of thing. Right, but that's ain't confusing.
Does it all work? There's no thread.
It's the grid stuff. There's a threads issue.
Yeah, especially with the false color. Page 3 channel, let's say.
It shows how ones that I didn't use issues to differ. It's quick and dirty, right? There's no interpolation necessary. It's also results in cyan clouds.
Right.
What kinds of blue amendments? Why is iTunes? I don't want you to connect to my phone. Just leave it alone. Oh, less on interpolate, right? You want the averaging.
Because I would not.
It's a 4-point moving average filter. It's got to be in there.
Because I would not ever write indexing like that. It's just me being lazy.
My brain is broken and can think like that now.
I could get there, but I would
It's
not.
more like Keanu seeing the Matrix. I'm not sure which way I want to go with this. Is it Keanu seeing the Matrix, or is it, you know? The opposite of that. What time were we supposed to switch over?
I don't know the schedules. I would
Well,
say.
what time did you say? You said 10, 15 minutes. So
15, so that'd be another 3 to 5.
Okay.
Let's see. Feature detection, filtering.
I can see that as Ferengi filter.
Yeah, I know.
Well, this is the green band, this is the red band, we tried to have it, but it did it at every point. So you need to skip to that point, maybe need a small.
So here's scikit image mean filters.
You can see the
No, because I think you have to change the shape, it does that every pixel. Right, we'll do that, see how,
your one is downscale and one is straight. Yeah. For either.
right.
Don't you then make the points because we tried that just to stick it.
I'm not clear on that. It's already looking, because it's already put on actual lap bar, they don't have you get it. Right, so you need to take the lap bars and.
Right, so
So for.
so if you go up to.
There, so it's like getting there and filtered, or it's like getting image. Looks like they got two different filters.
In there.
Yeah.
Go line below that. Above return, above the return statement. Okay.
What is this?
Set. Auto underscore mask and scale. I think there's a parentheses.
Person file means.
I think it's doing the scale and offset. Is it or? I'm guessing it's the same notation. Oh, yeah. False. Oh, sorry, capital F for false. You need to run all they just do sell. Yep.
That was just probably 2 weeks. So you tend to push it. You tend to miss the morning low and the afternoon. Thanks.
Oh, yeah.
Yeah.
Even that's.
Now, oh, now we did it. You don't have to run them all, just run that last one.
Oh, okay.
So this is the one he accesses where you have something happen.
Somebody looking at this, where phase.
You just come in out our line, does anything else again? Do like this massive scale line? Yes, that's about a massive scale. Then you sell it off.
So as a quick survey before we get going again, who is planning on coming to the hack day? On Thursday. Okay, so a few people. Nominally, we'll be here around 9, but come whenever you like. The idea is whatever you're interested in, we'll talk about it. You want to learn more about how to contribute and work with GitHub, do some collaborative development, talk about that. If you've got a project that you're working on and you're stuck, we'll sit down and help you with your project in Python.
So you'll be okay if I figure it out January 11th?
That's fine, yeah. We will be leaving sometime just after lunch. to go get
So when you're SSH, should. So are you connecting to your? Do you have your one that says chain into configure so that it'll accept
I'm not sure.
You just update exports. I think there is an option though. You have to enable. You bring up exports. You go into preferences.
So just put there right on that. One more to the right.
Security.
So the
Yeah,
service
I'll
is
connect
just-
to network clients.
just reference it. Just gotta say np dot strt.
35 steps through there.
So what's happening is we pick either trial and error or loop through all 16.
I think you still need a Oh, you got it, okay. Oh, we're going to D-stack, yes. Wow, that is really good. Sure, sure. Okay, gotcha. So green's still a linear combination, but that would be said. That's right.
But make sure when you're taking the square root, it's from 0 to 1.
Gotcha. Because then it's still 0 to 1 afterwards. What just happened? Well done, Kevin. All right. Well, let's move on to what I guess will be our last section of the day. And we'll talk just a little bit about accessing some model output. You know, we've touched on point data. We've done satellite. We did upper air yesterday, as well as some SCF files in general. Last thing today is we'll talk about using Siphon to talk to a thread server and get some model output. It'll look very similar to getting the point observations, but then we'll also explore a little bit using that to do some contour plots. And then also briefly applying that to on the SKUT and looking at a quote-unquote model sounding from the HER output. And that'll be the last section of the day. I know, it's been a long 2 days, so I'm sure everyone's starting to get a little saturated here. So, all right. So to start, once again, I'm going to go back over to my friend, the thread server here, threads.ucar.edu. And this time I'm coming over here to forecast model data. And so we have a large collection of these coming over the Weather Services feed. Various versions of the GFS, the NAM. What we're going to work with here is the output from the high resolution rapid refresh, or HER. And so I'm looking down here at the HER from NCEP. And so we have separate collections for the analysis fields that come out of the model. So just no forecast applied, just a quick single time step of model physics to get all the fields consistent. We're going to look at actually the forecast output. So I'm going to click this here. And then I'm going to copy and paste that URL. Or that's what I would do if it wasn't already sitting there. It'd be grab this URL and bring that over to my Python code. So this top level catalog that's up here. I go back, that is not what I wanted. That's what I wanted. So that's where this URL that's in here came from. See threads.ucar.edu, threads catalog, blah, blah, blah. Catalog.xml. So that's the starting point. We just point, grab a URL to the catalog for the HER output. And then instead of going through and getting the TDS catalog class, Siphon has a quick little helper here, because if we look back over here, over to catalog, we've got this full collection. We have a lot of different, grid files here every hour for the last 3 days worth. The HER's pretty beefy, and it comes out every hour, so we only have 3 days worth of it. But at the top, not only do we have the full collection and this best collection, we have latest collection. And what that is essentially, you can think of it like a link just to automatically points to the latest available model run. And that's automatically updated for us. And that's sitting right here. From Siphon, we have this helper we can import from. So from Siphon catalog, we can import this function, get latest access URL. And it's a quick kind of a short circuit for parsing the catalog, finding the latest, opening it up, extracting a particular access method. Instead, we could say, get the latest access URL from this catalog. So we point at the URL we want to find the latest from. That's here. And we ask it, go ahead and find me the URL for accessing the NetCDF subset service. So one fell swoop here, we can get the URL that corresponds to NetCDF subset service access to the latest data set or the latest model run from the HER. Then, like before, we're going to, from Siphon.ncss, import that NCSS client class for talking to the service. And then we create an instance of that, pointing it to the URL we got above. From there, this is going to look a lot like the stuff we did with point observations earlier. So here, we're going to start by creating an empty query. And instead of hard coding the north, south, east, west of the box, another way we can arrange our code here is we'll say, here's the center point of what I want. And here's the width in degrees of the box I'm kind of looking for. Just makes it easier if you want to make, shift the box around. You can just change the center point, and you don't have to worry about adjusting, east, west, and north, south. You can just kind of adjust these two values. Before going on making our query, we want to see what variables do we have available with the HER output. And you can see there is an excessive collection of variables, including great ones named like hourly maximum of downward vertical velocity in the lowest 400 HPA pressure difference layer 1 hour maximum, which is translation of grid encoding of some field here, which is defined as the 1 hour maximum in this lowest vertical coordinate system of this and that. So it chains these things together. Threads is trying to make a unique name out of that. And so programmatically, this is the most robust way we could do that, but you end up with some pretty horrendous names. But honestly, I don't know when I'd ever ask for that output. A lot of this comes from the fact that, so it's easiest to make it available on AWIPs just by sending it across rather than having AWIPs generate the output. So somewhere in there, we saw, okay, there's temperature isobaric, there's temperature at a temperature height above ground, which means it's temperature at a fixed height above the ground. So that's where we're going to find our 2 meter temperature. To really know that, you'd have to go digging into the metadata and find the coordinate variable that holds the height and go look at its value. We're not going to bother with all that today. Just it's the 2 meter temperature. So now we found what variable name we're looking for. So now I can say, query, give me all times. I want it back. Before we were saying except netcdf. This time we say netcdf4. The subtle difference there is there are a lot of implementations of netcdf3 that you don't necessarily need the compiled libraries. netcdf4, there's pretty much only one. But what the benefit gives you is you can get compressed returns. So the data are much smaller if you're using netcdf4 rather than anything else. And so when we're downloading model fields, that compression can save you a lot of time in terms of transfer. So we tell query, give it the variable, our temperature, height above ground, and then we'll make a long-lat box request. So here's where we make use of the parameters we set above, and we say north is our center latitude plus half the height, south is the latitude minus half the height, and similar for the longitude. From there, we say get the data. So we pass it our query again, just like we did this morning. Takes a little bit longer because the server's got to go slice and dice some grid files. We did ask for all the forecast time, so it's got to go scanning through there and find all the records, and then it's got to return it. It's completed. So we can look at what we got back. We got ourselves another netcdf file. Great. We've kind of beaten this horse. We've done this several times over yesterday and today, pulling apart a netcdf file. So here I'll set a variable with the the name that I want to use so that I could more easily change it, although I should probably really have that up higher to change it in one spot and have it propagate throughout the code. But I'll set this here, grab a reference to the netcdf variable for that, and we can see things like, here's all the grid information if you're curious, the parameter name, the category, the parameter discipline, and so on. And of course, we have units. They're in Kelvin. Here, just like we saw with the satellite data, we have this grid mapping attribute that tells us where to look for the projection information. So it looks like we're going to be looking for a Lambert conformal. We're working with a Lambert conformal projection. So, like John did, I'll use that attribute to pull out the projection, the variable with all the projection information. So we have, it's a Lambert conformal conic. It's centered at 20, or the latitude of the origin is 25 degrees north. The longitude of the central meridian is 265 degrees, which -95, I think. And it also has the Earth radius. So we'll go ahead and pull out all those attributes so we can set up the CartoPy projection. So here we've imported CartoPy again. We're also importing MetPy to handle some unit stuff. So we'll go ahead and grab the X and Y variables here. So reference a variable, slice out all the data as a NumPy array. And then we'll use MetPy's unit support. Instead of hard coding units here, what we're going to do is we'll just let Pint parse the units from the netcdf file. So we take the units registry from MetPy using Pint, and using its ability to parse an expression, we'll hand it the units string that's in the netcdf file. That should be a Y. Don't think it makes a difference though. But most importantly, we see the units on those projection variables are kilometers, which will not make CartoPy very happy. It really wants things in meters. So that's why we're using the unit support. From there, we can just say, take X, give it to me in meters. Same thing with Y. So now we got it in meters. Set up our globe and our Lambert conformal projection. One other thing to look at here is we see what shapes, how many grid points do we have. So we see for X and Y, we've got 949 points along X, 973 in Y. And the last one, our variable actually is 19 by 1 by then YX. So we've got one vertical level, that's what the 1 is for, and we got 19 forecast hours within the output. So we're getting close to being able to, make a nice plot of this with all the information we need. The last thing we want is time. So it would be nice if we could just ask for the time variable. Unfortunately, the way grid files come across, when you're just getting a message that has one 2D slice, you may miss a time or two, or you may have different variables with different, essentially time dimensions. You may have a 6-hour average rainfall or 6-hour accumulated rainfall, or other things on all these weird different time dimensions. And because you're just sending individual grid messages across, you're not sending a big 20 gig file, the arrival order of these messages is very arbitrary. And so Threads does its best to rationalize these, but you end up with this effect where the first one to arrive gets the dimension time, then succeeding ones get time 1, time 2, time 3, and so on. So to deal with this, we can go back and look at our variable, and we can look at the coordinates attribute. And that tells us what ones we should be looking for the appropriate coordinates for that variable. We see y and x, that's fine. We see a height above ground 1 is what we should be looking at if we were going to look at the vertical coordinate information. And we see the name of the variable that holds the appropriate times is called time 1. So if we just pull that attribute out, we can see it there. We could just hard code this here if we wanted to, just say time 1, but our script would break, depending on what happened with the grid messages on the server. So instead, what we can do is just write a little bit of code here that loops over. We take the coordinates attribute. We call Python's split function. That's part of the standard Python that allows you to take a string and split it on white space, or if you pass a different character, you can split it on that. So now we have a list of different strings within there. Basically a list time 1, height above ground 1, yx. And we can just loop over them and find the one that has the word time in it. So that's what we're going to do here. If timing coord, we found the name of our time variable. So we'll grab a reference to it, and then we'll break out of the loop. And this way, our code works no matter what the server does. If it's time 4, it's time 7. You think I'm kidding, I've seen up to about 10 if the grid collection is big enough and has enough missing chunks and different things. So we'll just run that, and we see, okay, here are our times, and we've used num to date to parse them apart again, like we've seen many times before. So for instance, time 6 looks like it's a forecast for 1Z on the 7th, so sometime this evening. So real quick, let's see where we are. Okay. So now let's visualize what we've gotten back. Once again, we'll set up state borders, importing part of my feature is cfeed. We'll set up the state borders again. We'll put a variable up here to hold which time step we're going to plot. We can plot 0 here to start. Create our figure, add the subplot. I'll go ahead and grab a color map called Cool Warm. That'll give us a little bit of red-blue coloring for the contours. I'll also set the plot range to go from, looks like I have it going from plus or minus 30 C or 243 Kelvin to 303. Go ahead and grab the data out of the variable. So instead of having like the manual temp var or whatever, we just have a generic variable. We grab our time step out of it, squeeze it to get rid of all those, the size 1 dimension for height in this case. And we'll go ahead and make it go ahead and attach the appropriate units to it using the attribute on the variable. So really, besides hitting a model collection and maybe structuring the code a little differently to try and be a bit more flexible, the big new thing here is, if you haven't seen it before, here's how you can make a contour plot with Matplotlib or HardPy. We call this contour function. We give it our x and y coordinate values, as well as the data we want to contour. We also tell it, when we're plotting, our data are already in that projected space, because that's what the output has, is the data on the Lambert conformal grid. So when we give it x and y, we need to tell it. Here I'm just making a generic Lambert conformal grid, not necessarily specific to what her is doing. Here I'm telling when I'm plotting that her projection I set up back here. That's how these data are referenced. So it makes it easy if we wanted to change from Lambert conformal to Robinson or azimuthal equal area or some other projection here. We could change it right here, and our data are still referenced properly using the her projection we set up.
On mine it says PC color mesh. Contour.
Okay. I must have changed.
You do contour in the last one.
That's what it was. Well, let's put it back to P-color mesh. This is what happens when you don't reset your repository. Yes, I do. Okay. There's P-color mesh. If I run that, I got other problems. I don't run my import. That's my problem. Okay. So P-color mesh is similar, but in this case, what P-color mesh is doing is not contour analysis. It's allowing you to plot plot a mesh of quadrilaterals out there. So and color map each individual quad based on the data value. Very similar to IM show, but if your data aren't regularly spaced, which the projected variables out of the HER I don't think are, that's where this comes in handy. Good for radar data, good for I think some satellite data where you have irregularly shaped pixels, things like that. So that's what we're doing here. Then we're back to the standard coastlines, states, borders, grid lines. We set the title. We call this ISO format function on the time just to get a quick ISO formatted string for the date time. And then last but not least, we add a color bar. You know, we had a lot of questions about that from satellite. So just to go over it again, we could take our figure reference and say, give me a color bar. And we saved mesh up above. And we can pass that here to say, this is what we're coloring. So pull the information you need as far as the coloring of the color bar to match from that. And then we can also set a label here. Maybe not F, but we'll spell it out. And so that's how we get a label here on the side of the color bar. Of course, I didn't actually use the color map, so I should put that back in here and say CMAP equals CMAP.
So like the units package doesn't have a long name that you can pull out of it?
Let's see. Let me find out. Oh, hold on. I'm converting it here. So what I really want to do is take that out of that call, move it up here and say, I'm going to do this and say, if we use I2 instead of just 2, it'll do it in place. So I'll change that. Now it's converted to Fahrenheit in place. And now when I go down to set my label, we'll say mydata.units. And hopefully that'll work. Gives you DEGF. It's not great. I think there are other formatting options we could go with to try and get a longer string, but that is more robust than hard coding F. So
You scroll, pull that. Sorry.
sure.
What's the advantage of doing it in place? It's not going to apply it after?
It's shorter than writing this.
Oh, I see. Sure.
Or creating another variable called plot data and doing it that way. And any other questions about what we just sort of walked through? Okay. Once again, we have a separate notebook over here, model data exercises. So let's, walk through it, try doing it on your own. Let's, you can pick something other than the HER. You could use the GFS or the NAM or technically any of the ones in that catalog should work just fine. Got the wrap or the Sref ensemble or Wave Watch. So now's your chance to, try it on your own if this is what interests you and see what steps were unclear so that you can do this when you're not here.
So Ryan?
Yes.
So here you're kind of hard coding the range. I see
Yeah,
a way you could pull out like the max and the min and kind of dynamically.
So you could, and honestly what I've done here, and that's just, again, one of those things that I really should have cleared my notebook before doing this, and I apologize for that. I'm not actually even using that plot range. I don't know, let me see what version you have.
Well, here I still.
So I'm using norm. We just take out the norm. Matplotlib will take the min-max. The reason for specifying it is so it would be centered with the white band at 0 Celsius. But that's an arbitrary distinction, and it is more flexible just to not use it. Of course, then it becomes, depending on which data you're plotting, cool, warm might not even be an appropriate color map to use. You might also, as playing around with this, explore, using contour, or there's contour F for doing filled contours. You find something. Oh. Well, I should be running on I usually just go through the clone when we do Git. And run out of that, and for some reason I'm running out of my repo version, which I never do. Me.
I think it's the range that you're calling. Yeah, like, you're not gonna see much variation. I think it's just the way this is on those variations. Whatever strong green. Surprising that was that. But there's.
Oh, yeah, they'll change this code. Right now, it was kind of the.
You divide by, this is back out, right? Divide by 100, give it to 100. Why not? Show them. Very close to juice up.
Do you need to juice up?
Not yet, not yet.
I haven't totally juiced up.
No juicing.
Oh, that's good juice.
The best juice.
Can I show you how I've been historically have been doing my projection?
Say I want to use one of your MetPy tables to.
So you create the globe object and everything, and from reading the documentation,
Similar to.
I found that just has to do this. Is that
That's enough if it's WGS84. If it's like a spherical Earth assumption, you might need to create a globe and say it's a sphere with a certain radius. If you got it.
But with, I mean, with her, you know.
If the Hertz on WGS84, then you're good. I'll just
have to look to see if that's actually the case.
Okay, so this assumption only works if it's.
whatever the default
WGS
globe in hard height, which I think is WGS84.
Okay.
Granted,
CMAP
we were talking about model output. You might shift the grid point.
equals.
Registry. I'm having the barbecue, but across the street.
Yeah.
All right. Okay.
But I've seen somewhere that the spheroid really matters, for some really lining up coastlines with shape files and whatnot.
Right.
There should be two like.
It's probably good enough for her output.
Right.
First of all, most
But
applications.
you're like dropping.
I doubt it would be the most significant source of error in her forecast.
Yeah. Oh, and the feature collection works.
And then the name of the code table.
That makes me just want to say, we're probably doing the same files in GenTech format.
Yeah.
On our system.
Yeah, so I mean, we should test it out a little bit and see how robust it is, but. As long
Can't
as
be
it's
any
parsing,
worse.
as long as it's parsing those GenTech files, okay, I mean, I know the GenTech data is fine, so. If you're not dealing with some huge sync list and CDF, could be the way to go, but on the other hand, maybe.
Well, it might be a stopgap until my preference would be to have get data, go through a Python script, produce necessary files. But that may be a longer term, and I really, after today's destruction, don't feel good about what we're doing. Might also get us upper air files on thread server.
Oh, is that not currently?
We have some that are being produced in NetCDF format, again, NetCDF Perl, that I don't feel particularly confident in, so our GenPack supports solid in NetCDF Java. Yep. Probably a better way to go about it.
Oh, they're backwards.
Then you can try the one and see if it
I've just never.
Okay.
It's one of those things where I look at the documentation here and going from this to that is kind of mysterious.
Sure.
It's easier to see an example than to, I mean, I found that with a lot of Python documentation. I look at the documentation, I'm like, I don't know what to do with this.
Okay.
You know, they're defining classes and objects and things that I don't know how to translate that into my code to make it do things. You know, like.
Documenting the thought process and some more expository stuff.
Well, just for example, here you say from MetPy.class.ctl was import registry. I would not know where even from this page, just showing the different color tables, that was even a thing. Color table registry.
Yeah.
I don't.
Yeah, no,
maybe it's just getting more familiar with actually working in Python, and you know that.
Yes and no. I think so. You're right. There's some steps in the path that are missing.
Yeah.
Actually, the path is probably more like a little overgrown. You need a machete to get through.
How do you list all the attributes?
If you just want the attributes, .nc adders. That's the font method to call.
.nc
ATTRS.
So I've got some great plot bar.nc adders should be going attributes.
Say it again.
That's pulled some grid calling it plot bar. It's got 3 dimensions, but I don't know what dimensions.
Is it a netcdf variable or is it a something? Then yeah, NC adders. That'll give you the attributes. You want the dimensions?
Well, I need to know. I know what the shape is, but I don't know necessarily which corresponds to what.
AWIPS tomorrow, right?
Yep.
How much introductory level experience do you need for AWIPS?
Michael, how much introductory experience do you need for AWIPS for going tomorrow?
Okay.
Sounds good. All right. I guess we'll see you tomorrow.
Yes, will do.
Okay.
I do
No. I forgot this one. So he wants to change something.
I get this, which I assume is latitude longitude 26 here. I don't know which is which.
Yeah. So if you look at
I was just sort of pulling off of this grid.
plot bar is the variable, then you should go to dimensions, I think.
I would make a second of mesh bar.
That's the whole thing about the grid messages coming in your order, not being able to just. They're not always the same time dimensions. You have a missing variable for one of the forecast hours, it's got to be its own time dimension. You've got
No, I don't.
whatever.
I don't.
It gets very, very hard to make a cohesive set robustly in a program. You know, human can say, well, it's really only one missing here, so we'll just flag it as missing and go on. But if you've got like, out to 12 hours, you've got cape and temperature, but only temperature beyond 12 hours. Cape and temperature are going to have separate time dimensions. Okay? Now, which one ends up time 1 and which one ends up time 2? Depends on whether the cape arrives first or temperature arrives first. So that's why you have a time 1 versus time 2. That's where you look at the coordinates attribute and see.
Yeah, well,
this every hour.
Oh.
Else. GFS.
So did you attach?
Oh.
Okay. So
Yeah.
you must know that you could
And I know that's an analysis, that's a fixed.
List.
List.
so it could be times.
Yeah.
And then
So I think
NCR.
some of these documents.
Okay, just like you know, you can just
So
pass
that's
plot
part of
part.
the units as a string.
Oh, okay, because they're gonna have a lot.
But I don't like the
So
fact that you can't, like, that works for all the things, I did not on data,
Parentheses.
written that doesn't work, even though it has one, so of course, thinking we need to fix something on our end, so that that should work, even just before this. But for now, plot create. I think we have other examples that do GFS, and I think we always cheat and just don't even think about it, because we know it's GFS, so it's on a lat long grid, so we don't even worry about it, but if you're programmatically writing one application that did this, that.
Let's try that. Different variables?
Sure. Are they, well, you need to change your.
I'm just saying, this is what I get for.
Right, so your problem is there. There's your request, so you need to request it too. So
Okay.
if you could put this up there, and then these variables just pass bar there.
Okay.
That would be the more robust way, and I really should change my example to do that.
You need your data bar.
Yes, whatever we do, the next wrong group. See, that's a surface pressure. And it's uniform on the work. Except for here.
No. This is just no, I understand.
Kills up.
Hey, Brian,
Yep.
do you notice that her solve over the like Great Lakes? Like they've got flat pressures across the Great Lakes.
Almost every. And Florida, I guess it doesn't like Florida.
I don't know.
I don't know physics.
But it's only over those two spots that it's,
Apparently Florida, like.
Yeah,
But I mean-
most of Florida, there is some pressure on other, some other people.
Applying pressure or sea level?
Surface pressure.
Surface pressure.
Yeah, surface pressure.
It's probably not gonna.
Very, very.
surface pressure from not all the signal cords. It's not a bottom, but it's a good.
Just have a contour range from, let's say, 1,000 to 14 versus.
What was the plot range before?
Oh, it is.
You're very 300.
Oh, wow.
And that makes it.
Yeah, see, that was almost a topographic map for the US too, where that was.
Oh, it's still, this is not used to the range.
Yeah, it's gonna have 800. So you're seeing the map, and you're seeing it as we get to Colorado.
So normalize is not the way to change the range.
Well, it is, but we need to pass it.
Oh, okay, I see where it. It's like,
That'll do it.
let's see, I'm very well known in introducing very
Your bottom is too high. So we're going to 980. I mean, because you're going to 800 before, go 980. You could go at least 980, if not like 960.
This is not MSLP, this is surface pressure studio. Not here something 60.
Okay.
Now, once this is meant to be, you just do that data, just as it's on above, or no?
You want to stick?
Just the normalized.
You on mesh, so you can take that mesh object that's returning, and I think set norm, all the below the display the figure, that would work.
Okay.
I think. It works for images, I can't remember if it works for mesh.
So kind of, when you're doing, you might want to write that object,
Yep.
return that object to yourself all the time. You're always going to be
So certainly, if I don't do it that way, I might not have a problem making the plot, but my data access will be in a separate cell. So I'm not continually going out and downloading. That's usually the slow part, is making the request for data.
Right, okay.
That's where the notebook excels for development versus a script, is you have this state you can hold on to and keep twiddling just little parts of your end display or something while keeping the data around.
Yeah.
As long as you're careful about not making sure you clobber your data that you're reading in.
Yes.
Like if you get confused, then you have to reread it.
Right, yeah.
All right,
Yeah.
there you go. It's like 2 days.
I'm so sad right now. Well, no, that's beautiful. I'm sad about not having that before. We all still grossly incontent staring at model output? That's great if you are. If we're ready to move on, then we can, close out. It's 4:20 on a Tuesday. I think I see enough to. I'll run through. I wanted to just show you the other part of the model request here. So we did a request for a subset of the grid. So you don't just have to make a request for the grid. You can use this kind of as a get my forecast for my location kind of thing. So it's the same kind of thing. We're already still pointing at the same data set. We're just going to set up a new query and get all times. Again, get it as an SCDF4, but we're going to ask for temperature, dew points, and the U and V wind components. And then we're going to ask for just that particular center point. And so as opposed to getting a grid of data, we're going to get the data for the closest point to what we request. So we could use this to get a time series temperature forecast for our location. Or we could use it to make, a quote unquote model sounding. So we could take what we get back as I wait for the server to finish sending me data, or actually probably go and assemble the data from all the different grid messages. It's taking an unnaturally long time. Well, once that returns, what we can do is we can take our SCDF data, pull apart the pressure, temperature, dew point, U and V components, do a little bit of unit manipulation and slice it, squeeze it, get the particular time step we want, because we've asked for all times, so we get a series of different time steps here. Convert our values to, for plotting on a SQT. So get it to millibars, degrees Celsius, and get the wind in knots. We can plot it up and get a nice model sounding with one problem, and that's we really only have the mandatory pressure levels, which makes for a really, really boring sounding, and it really only goes up to 500 millibars. So really just a good example of, going back to where we started with the upper air stuff and saying you can combine that with, any data source you want, including, a point forecast from NCSS. If you have the model output, if you're running, say, her locally and you can dump all the vertical levels, you could do something better. But using NCSS, we only have on the server, the data for looks like 5, 7, 850, 1,000, maybe 925s in there, but otherwise, it's not a lot to work with here. But we could also go ahead and make a time series plot if we wanted to. So just the last thing I wanted to talk about was NCSS and your ability to not just request a full grid, but just do, some kind of point forecast, or just extract the data or output for a point from those grids.
Make it animated sounding.
Yeah, we could use this to make an animated sounding, although again, I'm not seeing enough variation to do something interesting here. So that's what I got on this. I thought I'd show you a few more resources, for learning more and seeing what's going on. First thing I want to show you is if we look for Unidata mailing lists on Google, you go to this Unidata support link, and under mailing lists, we have a whole wide array of different mailing lists for our various projects. So if you want to ask questions or stay up on announcements, this is a good place to do it. We have our Python users mailing list. That's a pretty low traffic place, but if you have questions, that's a great place to ask them, and either John or I, or hopefully someone else in the community will have an even better solution than one of ours. It's a good place to look, ask about resources, or I can't get this to work, what am I doing wrong, kind of thing. Another place on here, I think John pointed out, he was talking about the developers blog. So where is that on here? So if I go back up to news here, we see news from Unidata, and there you can follow looking for announcements for software releases, things like that. And then the developers blog, as John alluded to, we'll start doing some more regular posts on quick things using MetPy or just Python in general that applies to the problems we're all interested in. Let's see. So we've kind of touched on this, but off of the MetPy documentation, we've talked about the examples and stuff. There are other ways, if you want to communicate with us or get a hold of us. We mentioned here the Python users mailing list. If you run into any problems, feel free to open up issues on GitHub. We like having those. Those are good, easy to track and make sure we don't forget about things. That goes for Siphon as well. Siphon has its own GitHub repository where you're welcome to open up issues. MetPy also has this Gitter chat room, which is done through GitHub. All you need is a GitHub account, and it'll authenticate through that. And that's where we're generally hanging out during the day and can do more real-time type communication. Because sometimes trying to go through a mailing list or through, GitHub issues can be a little bit slower than just being able to go back and forth, in the chat room. So we have that available here, this Gitter link. And if you're on Twitter, MetPy has its own Twitter handle as well, @MetPy. So all of those are regularly updated with, announcing all our software releases as well as other relevant things. MetPy doesn't eat food, so MetPy doesn't put pictures of its food on the Twitter account. So nothing to worry about there.
Cats?
No cats. If we figured out how to plot cat data in a weather-related way, we might do that.
How did you get to that blog page?
So if I go back to www.unidata.ucar.edu, so are you able to get here? News from Unidata, and Unidata developers blog. I'm pretty sure, but I will verify. Unidata developers. Actually, if I just do Unidata blog, yeah. So the first two hits on that are
You cross-post that site from the MetPy site? I don't.
So MetPy doesn't really have its own blog. We'll go through the Unidata developers blog for non-news posts, and then we'll put software releases on the Unidata news blog. And those definitely cross-post to Twitter and the mailing list as well. A couple other projects of interest. So we linked to you when we sent out the announcement for the workshop, the online Python training stuff for more entry-level Python things with a focus on geoscience. So there's that. What I wanted to call your attention to is also the Unidata Python gallery. So we have this gallery up. So if we go to this page, we have a collection of various examples. Where MetPy has its examples, it's very focused on different pieces of MetPy functionality, and it's not accessing any live data sets. So this gallery, its whole purpose in life is to be able to do any kind of, it can be MetPy, can be Siphon, can be a combination of those. It can involve other things, but good integrated examples of solving atmospheric science-related problems. So for instance, we've got plotting a meteogram and accessing live data from threads and going through that with Siphon and plotting that up and making this plot here. Or we've got, making a map of 500 millibar vorticity advection and how you would go through and do that.
Did that come from the stuff Kevin was working on?
Yep.
That's cool.
So recently we had a faculty member spend a month with us during a sabbatical and reworked a lot of these examples and cleaned them up. And we've got things like 500 hectopascal temperature advection, or a nice hemispheric plot. And we definitely take contributions there. So you don't have to be, hotshot coder to make some intricate feature. Just examples saying this is something I found interesting. I'm proud of this map I've made. We're trying to build a community resource here. And so examples you think are relevant are probably relevant to a lot of other people. So by all means, feel free to send us. These are Python scripts that can generate then into notebooks, or you can download them as Python files. But we take them as, they are actually Python scripts. Is how they they'd be submitted. Let's see.
And we're going to freeze. We'll tag everything, the notebooks, as they were for this workshop. Yep. And on the workshop webpage, down at the bottom, it says past events. There will be a link for this workshop, and you can always get to everything as it was.
Yep. So down at this bottom, so the workshop main Unidata Python training workshop site, if you go to the bottom, past events, there'll be a new link here for this workshop, and those materials as they existed going into today will be available from GitHub. One other thing to point out, on the main package, the main Unidata Python workshop website, we do have documentation links for the various libraries we've used here. MetPy, Siphon, Cartopy. I want to call your attention to Matplotlib's documentation. So if we click that, we can go over here to the MetPy examples and gallery. So in there, if this will load, you've got just a large collection of how to do things in Matplotlib. And so a lot of how we've learned over time how to do these things, how you can do things like set up Matplotlib date ticking and things like that, comes from flipping through here and seeing, oh, that looks interesting. How do I go about doing this chart? And so you've got the image, and then you've got the code that's behind it. This one's pretty intensive. But I'm not kidding when I say Matplotlib can pretty much make any plot you want if you're willing to dive into it far enough. And you've even got, like, they call these Sankey diagrams, which are like these process diagrams for, calculating, I guess this is how energy goes through the system. But, just a wide array of examples, customizing things or weird plots or doing, all sorts of things. So even if Matplotlib's API documentation isn't always clear and it's hard to dig into it, these examples are a wonderful resource to kind of find. Right now, there's a lot that's actually trying to restructure things and clean it up a little bit to actually, you suffer from too many examples here and not knowing where to go. So that is an active effort they're working on trying to make these more accessible.
Path to get here again.
So it was linked on the main workshop website, but it's matplotlib.org. And then you just want to go to either examples, which doesn't have the nice images, or if you go to the gallery, you've got them with all the pictures. And so, for instance, here's an example of showing all the different line styles and how you can do custom dash patterns. So that. Yes, the last thing, please, before you go, and we'll probably send out an email reminding this, but if you don't mind, on the workshop website, go back there. So on the Wisconsin workshop website, under feedback, we have a link to the survey. If you guys wouldn't mind, take 5 minutes and fill that out. Let us know how we did. There's questions in there asking, suggestions for areas of improvement, whatnot. Really does help us, frame how we're doing things in the future. So I can say feedback from the last time we were here definitely helped shape how this one went, and we'll continue to iterate and try and do better. And then, along with that, your red and green stickies for the day. Just you're good for the day and you're bad for the day, if you don't mind.
If you want more stickers, anything else like that on your way out.
Yep.
We're happy to give them to you. We got a pile.
Otherwise, we're done. Thanks for coming. Michael will have you guys tomorrow with AWIPS, for those of you going to that. And then anybody coming to the Hack Day on Thursday for more just kind of informal, help you guys, try and tackle some problems, specific to what you're interested in, or anyone interested, we'll talk about, we can talk about GitHub and MetPy and how to contribute, and just general, more informal, gets you working towards what you're interested in.
So the AWIPS part will be in Cave tomorrow?
AWIPS is in Cave tomorrow.
In the second floor, that cave?
Oh, no, we're doing it in here tomorrow on these computers.
Tomorrow?
Yep. Any other questions about AWIPS? Michael's the best to ask about that.
I'm back here. I'm going to keep that class tomorrow. Full day of AWIPS. And we'll touch on a few Python examples. They use the
If you give me MetPy keys.
Should we try downloading it with like the Cave installation?
For your own computer?
Or are you going to come it up tomorrow?
MetPy keys? That's awesome.
Things like those are products.
I'm happy to, just don't set it to your phone number. Sean did that for a minute. Like, I can't get my codes to log into this stupid thing.
No.
No.
Oh, did you guys take it yesterday?
Yeah.
Oh, okay.
It's one, do it multiple times.
Oh, here, give me a second.
You guys back tomorrow, or you're not coming back?
We'll be here. We'll be around tomorrow if you got questions. And then we'll be here, like I said, Thursday before I think our flight's at 4:45. So I'm going to not log in on screen. So just give me a second and I will.
But you are on the webcast.
Actually, I don't think I'm logging in at all here. I just need to change the collector.
Yeah, sure.
All right, you should be able to log in again. Thank you.
Oh, yeah, I guess I said I wanted to scan it.
Or just make it PDF.
Reboot it, then open up the preview.
I have like hundreds.
You put your signature on it.
I think I showed it in the beginning, but we kind of said, yeah.
Yeah, we just reboot it. That's real.
I can't stop laughing at that
And we
one.
can't really do anything. It's when you start
I feel like that's how I write code some days.
trying to, yeah.
I feel more like the dog with the tie and the glasses. It's possible. It says I have no idea what I'm doing.
There's some truth to the statement, fake it till you make it.
Also, if I file an issue, we need to fix. You use the Unidata logo as the no image icon.
Oh, and it's
and
black.
You didn't put a white background on it. Because black under alpha is a sensible default. No. They do.
La, da, da, la, da, da, da. Twitter really needs to make organizational accounts.
They do.
That just, hey, I'll assign that to more than one other Twitter handle. I really just have to go dig up the password somewhere in my LastPass.
There's one thing, one password does a really nice job of is, like I've got
Well, sure.
4 or 5 different Twitter logins.
LastPass does that fine too. It's I'm on LastPass and you're on one password, so we can't share it. Which is how I really want to do it.
One of this is right, one of this is wrong. But,
Well, I started with LastPass when I was still a Linux user.
I started with LastPass as well and became dissatisfied with they had the unlock with your thumbprint on the phone like a year after one password and stuff like that. The Lindy lives, she's on LastPass, or she was on LastPass, I switched to one password, and she curses me weekly for it. She just does not like one password thing.
Oh.
Comes to it again. And it'll always be on there.
And then the save or something.
What did I ding? Oh, that's great. How do I go to birdeye.com? Oh, I clicked a link in email.
So you should.
Yeah, that's correct, because it's on CD.
Right.
Yep. You can still pay somebody for
Right, but did you fix one?
yes, but you can, you actually don't, because if you convert it, transform it to Lambert, it won't change it. I can show you my notebook.
Good job today.
Thank you.
I had to kind of check out this afternoon. I'm behind on some stuff.
No worries. I know the feeling, and it gets to be a long period. A lot of it is just exposure.
Yep.
And if you're interested, hopefully you follow up.
Yeah. No, that's good stuff.
Great.
See you tomorrow.
Thank you.
See you tomorrow.
Thank you.
Thank you, guys. Thanks.
We're just gonna throw these in the folder.
That's fine.
Because there's not many left. So.
I have no problem with that. Distribute them, you have some around. I mean, Doug still has 3 bricks of those. I've probably got 2 more in my laptop bag, so.
It'll be probably 2 people in the workstation.
Well, we'll give them out at the, I think I'm gonna need to send for a BOF at SciPy for atmospheric. For AOS, we'll give out MetPy stickers. But we need, see what we could really do.
What we need is an air.
T-shirts,
No.
blast stickers at people, or bricks of stickers. The air cannon puts embeds in the concrete wall.
I mean, with some slight relabeling of my gutter, put the stickers in the ballroom. And it was a thorough distribution of
You
stickers.
wanted to kill my outro then.
And also the last time.
Sounds like that's the movie from Hong Kong.
No, I mean, the last time because you accidentally have a garter in it, we're accused of firing garters at SciPy.
You do it once and push it out.
You know, I think the sticker can be like.
If it's, I mean, I can do it at home tonight. There's
Thinking we need MetPy Sprint stickers. A special sticker you get only by coming to a MetPy Sprint.
Nice
Oh, yeah.
It's a sticker.
I think I should try it.
Oh, God.
Like a little cartoon.
But funny.
And some little action lines behind it.
Oh
Like
my
a journal.
God. Of course you do. Yeah, I still got plenty of stickers in here, so take one.
It says, President, you don't have anything wants to use on.
Understood.
Yeah.
I wouldn't have had you go through it if I didn't think there were people in this room who valued it. So-
I was too quiet.
yeah.
Yeah, people in the back couldn't hear.
Mhm. Okay. Good point. I hadn't thought about doing that for local, but that makes sense.
Yeah.
I was wondering if I could get another MetPy sticker.
Absolutely.
Good. Come here.
Okay.
Easily. I've got 2 MetPy stickers.
Oh, sure. Thanks. Thank you. Thank you so much.
Awesome. Thank you.
Give them to your friends, put them on street signs. Stop
For a good time, call MetPy. I'm telling you, I'm reaching that time. Who needs alcohol to for the Thanks, guys. Thank you.
I'm not using satellite data much, might not need it, but there's MetFetch here. Have you played with that at all?
No.
It accesses the archive and it allows you to get NetCDF. You can just go to
Which one are you talking about?
PC and then get the fetch. Something.
So the idea, I used to use something called Yellow Pages.
Played around with it a little bit. I mean, the major disadvantage I have is I can get the NetCDF file, but it comes back as a web. So it's kind of under development. So, but basically it allows you to grab from the inventory. You can grab what different data types. I forgot. But it, it basically just sets up a URL that you go grab.
Okay.
And then, you kind of like the way you've done it, you can just replace the various components of that URL. But yeah, I mean, that it comes back with an SCF is very helpful, but then you kind of have to get that comes back as that web request type thing. I don't know any other way of doing it, because I use like a URL request to get
Gotcha.
to this point. So.
But we can make that an accessor.
Yeah, okay, we could.
Yeah, we could put that in Siphon where you could make a programmatic.
Yeah, because then in small amounts, if they have access, because it does like you just have to sign up for an account, which is free. But if you have access, then you can get small amounts of it. They put a limit on how much you can take down
Sure.
a month.
Okay.
But then you can get cases from the
past.
Yeah. I think that's the same archive Unidata should be.
You probably have an archive as well.
Well, I think we're a sponsor, or we have an agreement with SSEC so that community members can have more, or something like that. Yeah.
Right, I'm not sure if the fetch is running under it, because like the first time I did it, I went up and I'm like, I don't know, I can't get any more data. And he's like, what are you doing? I'm like, I just keep hitting it.
By the way, yeah, we can. Yeah.
Yeah.
No problem.
I really would have tried to mark the acronym to the fly.
All right, let's fly. GitHub.com/Unidata/Siphon. Yes. Yes, sir. I've got my power cord, not my dongle.
It's okay.
Shut up.
I mean, the 5 o'clock ones.
Oh.
I'm gonna go dump this water out.
Okay.
So what's the number?
Well, I got to do something similar in a second too. So. It's good.
I will be implementing the drop shadows on my satellite images momentarily.
It's actually it's crazy to dig into, but otherwise once you know it, it's super simple.
It's super useful too. I mean, right now I'm using some puke color orange because it kind of works on light and
Exactly.
dark.
That's why when I did my first
it,
Genie one, I'm like, I wonder. I'm using the same method to do my fronts.
Yeah. So the fronts I have the power cord on too. Nice.
Yep.
Thank you.
Till tomorrow. Thank you.
See you tomorrow. All right.
See you mañana.
Thanks for the thread stuff.
Yeah, no problem. I tried very quickly the upper air stuff. That didn't work.
Okay.
Might have a typo in there.
Yeah. Okay. That was fun. You guys did a good job.
Thank you. We try.
Mm-hmm. That's appreciated.
All right, so there's a problem.
Uh-oh.
So my payment for the workshop.
Yeah.
I use my credit union card to pay for this when I signed up last week.
Okay.
Apparently, they didn't process it until maybe today. And because I'm moving, I closed out the account, assuming that it was paid back then. So I know I just realized because I just checked my email. I don't know if I can give you guys $25 in cash or
That sounds like a terrible idea. Just in terms of trying to do bookkeeping. Has someone from Unidata contacted you, or
Sherry
contacted you?
Yeah.
Did she suggest any?
I just got back to her.
Okay. I'm sure she'll have a better method for how
because
to.
yeah.
It may end up being call her and you got another card.
Okay. Because
Or,
I don't really want to put my credit card info through an email.
No, don't do it through email. At best, she's a person. She has a desk at Unidata. You can do it on the phone if that's what it comes to. I definitely wouldn't email her.
Yeah.
But yeah, that's for our purpose going to be the easiest way to do it too. So I can't believe they didn't process it right away. Or like last week when they closed registration, or why now? Oh well. Yeah, work with Sherry. She's good. She'll take care of it one way or another. Of course.
Nothing's ever easy.
No, never. That's always the way it works.
And being a programmer, that's life. That's life's motto.
Yes, get used to it.
Oh, okay. Good.
Should I get back to you, or? And I guess it's 3:54 in Boulder, so.
Yeah. Well, I got a no worries email.
Okay.
So
Unless Then just roll with it. I wouldn't.
I'm not.
Honestly, all we've done here is snacks, so I think really it was more about make sure people show up.
That was really the idea behind 25. I mean, if it would have been just us, I probably wouldn't have had any fee, but
Sure.
having people coming in from out of town, it's kind of like you get a little skin in the game. You're more likely to show up and not say, I don't
Bingo, and take seats.
register because you might come
Yep.
and we get, 15 people.
Yep, exactly.
Well, I
An RN can you go to?
more solid attendance for tomorrow.
So I know you said you were flying back.
At 5 o'clock, which means I might be able to get down for about 2 hours.
Okay, sure, yeah. I mean, we're gonna cover the introductory stuff.
Okay, and that's
the interface in the morning, and then, so we're gonna get into details.
Okay.
Come for the morning.
Because I've never used Davis before. I think the introduction would be, if I can just get the introduction, that would be perfect.
Yeah.
So, all right.
All right, so you guys will hang here for a while. I know you said you'll go out tomorrow.
Yeah, tonight I can't. I need to sleep.
I'm hopefully going to sleep tonight.
Yeah. Well, you're done. You get to just kind of hang out.
You know, that wasn't even on my mind last night, because for some reason last time my brain just decided to have, not even dream, just racing about NetCDF for like hours last night as I'm trying to sleep. What the? It was not a fun night's sleep, I can tell you that. It was not restful.
Wow.
So the night before was, I binge watched Breaking Bad, so I thought about Breaking Bad. I'm like, oh my god. If I do something too long during the day.
So today you're just gonna be, it's gonna be a Python.
No,
right?
it's not. No, what's sweet.
It's like an AMS conversation. Hotel bed, and I'm always anxious about my call.
I can't remember if it was a USUCOM meeting or at AMS last year, but there was one night where I woke up at like 3:30 and I just could not fall back asleep. I'm rolling over and I was like worried I'm not gonna wake up when the alarm goes off. And I was so tired and I couldn't fall back asleep.
All right, so you're hanging here for a while, Mike?
Yep.
Okay. I think where are we gonna go? I think we're gonna drift to the Hopcat. Not that precludes us from going there again tomorrow.
Okay.
As it was, we stopped last night and I got a round and watched the softball team.
Because it was kind of on the way. They won, didn't they?
They did win, but we only watched like a few innings because it just kept going. I think we watched from like 11 to 13 or 14 there.
I think it was 12 when we left from.
Okay. I have no better suggestion. I just feel like beer. There are 130 beers.
There are.
And they have some on deck, so they might kick some while we've been here, maybe.
You know this place, Brasserie Beach?
I've heard of it. The beer, I guess, yeah. Bill Claire was telling us about that Brasserie Beach.
Brasserie Beach.
I've not been there, but she said they had good beer.
It's actually walkable from here in Southwest. I was gonna go
It's
there.
the opposite of the direction you're going.
Oh, it's Southwest. Oh, okay.
That way.
I've heard that too. Never been there yet. Not unless I'm gonna get there before tomorrow.
That's awesome.
Oh, weird. Why?
Because it comes in the center, doesn't it? So it doesn't always look like that, it will fill out.
Eventually, the most recent look there. Yeah. Does it do that in the weather service too?
I don't know.
Because they're getting the same data.
I think so, yes.
That would be annoying as hell.
You know, it comes in pieces, so 20 seconds later, there'll be a few more.
I think we'll find out.
It'll fill out once this
So you just restarted the server.
Right now, and overnight.
Well, I will go ahead and reinstall on these machines and the one across.
It's not critical. But I think I removed a couple of menu items.
See you guys manana.
All right, have a good night, you guys. What I've been doing with the broadcast, I think I'm stop kind of stop broadcasting. But I set up a YouTube. It's a hangout on here. It's called YouTube Live, whatever. If you're using our computer, I've got it set up that way. That silver ball up there is the microphone. It picks up pretty much anything. And we'll just set up before you start. I'll do one in the morning and one after lunch, where I'll start the hangout. We'll share the screen. We'll just let it go that way, and then I can flip between you with the camera or the screenshot on there, and that works out. Okay. Nice. It's probably on the 218 grid.
Well, yeah, but what I mean is the actual name. It is a 218 grid, but
why is it
I do
data?
not have that screen anywhere in the source code. Something is going on.
Well, a lot of my files are still named ADA because, a long time ago it was the ADA, and I'm hesitant to change because it breaks things. So it's all named ADA. All my goes data is in the goes 8 directory because, it's goes 12, 14, whatever.
All right, so all of the work I've done the last 2 days is already saved on the computer.
It's all, everything that we would, because you were logged in as you, not
Yeah.
as the guest user, so it's all in there. You can just
Okay.
grab that directory
Yeah.
somewhere.
Now, I'm just wondering, how would I be able to grab everything I've done and move it to, say, my laptop computer or
Google Drive, you can email it to yourself.
It's just a directory with files in it, and if you've got Python, no, if it's Windows,
Yeah,
the Python might be a little bit weird, and some stuff might not work. But a notebook on Linux should run on a notebook on Windows if the same modules are installed.
Okay. All right. So what different would I have to do in terms of like adding Python to a Windows machine?
Let's see, there's a mini common package that you can download and install. It's a GUI installer, and then it comes with shells. And I think you can install either like a bash shell or Git. I recommend if you're going to do like Python stuff on Windows, install Git bash, or Siphon or something like that. So but as long as I think when you install mini common